Ah, finally, live. I tell you, this is not my day today. Okay, hello everyone. I didn't announce the stream early. Let me start the TTS. Bitluni should be. What? Oh, Bitluni TTS join. Here we go. And nodes right server. So I had an emergency today and I just arrived. My hair is still a little bit wet because I had an emergency with the car in the middle of nowhere. We got stuck. I have images. Tony took pictures and she's enjoying a hot bathtub right now. And I decided to be with you today instead of hopping in with her in the hot bathtub. My hands are still frozen from the cold outside. It's raining and it was pouring, and I had to wait for help, like for emergency service, and guide them through. Oh, okay. I show you pictures what happened. I show you pictures what happened. So today's stream, first of all, I greet you all. Hello Adam, hello Johnny, hello M40K, hello Jody. It's not about the array today because everything goes wrong today and I don't want the array to break. So we will be just coding. If something breaks with code, it's all right. We can just start over again or whatever. Story time first. Oh, yeah. So the teaser to butter you up for today's stream, we will be coding a simulation or like a finite elements method simulation that it's so hard to explain, that generates a 3D volume and tessellates it to be, hey bleep track, no, not 4K intro. No. Even though I would love to, but I have a project to finish today as well, or like I have to promise to do this project. So we are like simulating, running an optimization simulation of a finite element method, and then triangulate the resulting volume to be manufactured with SLA metal printer at PCBWay. So this is the, it will be a heat exchange ventilation inset. So this is what I will do today. I spoiled everything. So this is a project. If you want to copy my project, you can do now. And I will code everything. We will use AI to do so. Why isn't Bitluni doing anything? Bitluni? I can't hear him. Is this broken again? Oh, fool. Yeah, classic. It's always my hands are cold. Now story time. Hey Wumpus. Story time. Why is my chair? It's like okay, here we go. I need a comfy. Oh, and I need to turn on my fondue here. Turn on the fondue. I did extra schnapps today, and I have like this Milka Easter bunny that I will eat completely because I was so cold outside. So our car got stuck, and where is the? Oh yeah, okay. So it's so stupid. Let me download because I don't want to. Let me download everything first, so I won't like show my private contacts on Telegram because Tony made the pictures, took the pictures, not made, like developing. Let's see, emergency. Okay, and I also noticed that the schnapps is like almost all gone. Oh, this is cool. Save as. No, where is it? Live stream emergency. We just like returned 30 minutes ago, so I barely had time to schedule. Okay, it's not showing the face of the guy that helped us. Cool. Okay, that is cool. Okay. All right. I think I have it here. Oh, by the way, Google checks the covers. I had the wrong cover. Have you triggered? Yeah, I have triggered it. I don't know what. Oh shit. Oh yes, it's my fault. I'm sorry. I didn't change the URL. My fault. My fault. Everything happening at once. Everything everywhere all at once today. Here we go. My fault. I'm used to not bitluni not working. Okay, it's deployed. Here we go. Here we go. bitluni coming to life. Hello, Ronald. And hello, Sniff. Yeah, here we go. Ah, yes. Yeah, triggered. Everything is triggered today. Okay, I hope it's finite element method. Okay. Yeah, we will be doing like we will be using ChatGPT to generate the code for us, majority. I think we can do I hope we can use 3JS. I don't know. I never used it before. Otherwise, we will just ChatGPT code a quick engine, and maybe we can. I don't know. Okay, let's show what was happening today. So we were checking out like two new potential bitluni labs, like new homes. We are looking like for super cheap house that I can renovate, and so I would pivot my channel to do a renovation for a year or two. And we visited like two homes. One of the home, like it wasn't great, like the weather wasn't great, and the homes weren't great. And one was like really remote. What? What is security intrusion? What is screen? Okay, here we go. Okay, so it looks like this place. Let me show that this place. Oh no, that's not the image I wanted. Okay, this is how we got stuck. You can't. Maybe you can see it. Okay, so this is like a tree stomp or something, and it basically somehow like by backing up the sensor was too low for the sensor, and we basically got stuck at like the metal part that's like connected to the wheel. So this wheel was a little bit lifted. Yeah, you can maybe see it like that. It was stuck like that, and therefore, oh, it doesn't show it. Oh, no, don't spoil everything. Don't spoil everything. Ah, wait. Is there, okay, here we go. Okay, here we go. Yeah, I don't care about this. This is not registered to me. However, look at that. this wheel was all right, still on the asphalt, and this is on the middle of nowhere. And the other wheel was like in a little bit lifted, so it would slip. So we couldn't just get back out of there. It was like super stupid. I tried like to pull up the car a little bit. What? I was driving, so I also gave like extra to the driver, like ten bucks for the coffee because when I called the emergency. He called me back. He was in the middle of his dinner already, and he had like to get out, and it was like pouring. So he took like he had a like he backed up with this huge car through like this is like a forest, and there's like a path that's barely as wide as his car, and he backed up like for a few hundred meters, and the road was blocked by trucks on a parking lot next to a highway. So I had like to get the trucks to move away so he can reach like this part where we got stuck, stupidly stuck. I mean, if this was like home, if I had like I would get it free in 5 minutes, but there was nothing. We had no like support, and there was like not even anything except the hook for the car. We didn't have like in our trunk. So that was stuck. I don't care about and wait. Okay. Does he pull already? Is this where I hope it doesn't show his face. Okay, so we took like the winch, and it was like there was one rope and a small mound was around a tree, because there was no way of him even like getting there in. So we had like to use the car. Uh, yeah, and that's enough. And that's enough. Okay, I don't want to show the guy. Ah, ah, I show everything. Okay, this is how it was like so simple, but I had to wait for hours, not for hours. Okay, it was 1 hour for the guy to reach us there and wait in the rain. So I was completely soaked. Even my socks were wet, everything. Not my chest, fortunately, but my hair still was. It's still like sticky from the rain. I have some tea now. Yeah, and that's why I was a little bit late today. And instead hopping in the bathtub, I'm here with you and having fondue. Yes. Oh no, it's not plugged in. Shit. Is it? No, it is. It should be. Oh no, it's on. Okay. I have to increase. Yeah. Yeah, the car was like stuck on a stump in the back. It was really stupid. This was like really minor. That's why nothing is broken at the car. Max, uh, I show you what happened since you missed it. Here, we got stuck like that. That was enough for the front wheel to slip, the right one, to slip, because there was no differential lock on this car. And yeah, fortunately, it was like at like this, basically the connection to the wheel, so it didn't touch anything crucial underneath of the car, so nothing is broken or whatever. But that was basically what happened, and it's stupid. It was in the middle of nowhere, and my yes, and everything is going wrong today. That's why I'm not doing any electronics. We will be doing coding now. Okay, and now that starts. Coding starts. At least the sound is working, like the microphone is working. Yeah, yeah, yeah. Like breaking the battery or something of the electric car would be worse. Um, and no one was hurt. That's fortunate. And the dude got like $10 extra. Um, and the guy got like extra $10 from me for a coffee because he was like he was standing there, you know, the winch, like uh, when he connected the car, he was able just yes, Dominic. So when we took like the winch, he could just pull. He unlocked it and just pulled all this long like rope uh, out for like what was it, 30 meters almost. And then when he disconnected it, it was still pouring, and he was like using the winch. He had to use the winch to roll up the rope again, and he was like standing there for I don't know 15 minutes for this winch and like this slow motion to wind up all the rope again, like the cable, the steel cable. What is in my? I have something on my eye that looks like creepy. What is that? Ah! 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 Oh, yeah, portable. I need, I don't need, I have everything here to solve a simple problem like that, but that was like in the middle of nowhere. I wasn't able. Oh, and at the end we had like even, oh, maybe I can show that. A double rainbow for on the ride back home. We had a double rainbow for like the relief. Oh, wait, let me check that. I can share it here. Double rainbow. Can you see the double rainbow on that? Let me, I don't know. Yeah, you can see it here. I have something else that I can show today, which is really cool. That's just to brag a little bit. Okay, just as oh, come on. Stupid acting up here. Okay. Okay, here we go. This was like, oh, you can barely see the double rainbow here. There's the, like this. There is another picture in which the double rainbow is more better visible, but I don't know if I can. Can I show it? Ah, here we go. Now you can see where I was driving today. Here, double rainbow. And there is the Amazon main hub in Germany. So, okay, here we go. And oh yeah, now I want to show you something really creepy. We can use this with the fondue maybe. Oh, what is happening here? We don't know if the fondue has the right temperature, do we? What do we do if we don't know what temperature the fondue has? Wait. Okay. Where is it? Tap. Video source. Video capture device. Add existing. Okay. Oh yeah, here we go. Here we go. Interesting part is like, do you see the pixels on the bottom corner of the? Oh, the whole it wasn't like that remote. Only like the road was like really in the sticks, but there is like reception, and there is also the house that we were visiting had also like, yeah, you can see the Kodos pixel. Yeah, I think this is like max min temperature here in the. I think there's like min max values of temperature conversion. Oh, you can even see the steam like this. But the reflection, look at the reflection. So apparently infrared is okay. This is me. Creepy. Look in the nostrils. Creep. Yikes. Yeah. Oh, this is the face cam here. It's heating up. This is Sony cameras for you. Yeah, still too cool. Yeah. But is that cool? Isn't that cool? Isn't that cool? Like thermal camera. I'm looking forward to like use it for videos. And if we test like current if the current specs are good enough with my PCBs, that will be cool. Like letting. Ah, ah. Yeah, that one even has like it can focus, so I can get like really sharp close-ups and also like far away. Look at that. You can see I can focus. Nope, that is the what is the name of the camera? I always forget. This is the Infree. Ah, shoot. Let me check. Infrared P2 Pro Plus, nee, 3 Pro, nee, Plus, Plus. No, I don't know which one. Yeah, it's not that. Or was it? Nope, that's not the one. Infrared is the camera manufacturer. Let me check. Which one is it? To S plus, no, T2 Pro, no, I don't know which one that is. Fool. No. Man. Okay, this is too hot. I can hear it cooking too much. I have it in my, wait, thermal. That's the T2S plus. T2S plus. T2 Infrared T2S plus. Can drop a link if you need that. Okay, here. Might or might not be affiliate link. Here we go. Okay, I will disconnect it. I don't want to break it. You know my luck today. Yeah, but the other one without focus, which is also cool, you can use Mike Electric's Mike Electric stuff. He reviewed the one without the focus, which is already great. That's like cheaper. I saw it even for $250, and it's quite high resolution and quite good refresh rate. So if you just need a high resolution, then I would really check it out, because like the old manufacturers, like what was the name, the cameras in that range of resolution and frame rate cost a lot more. Yeah. It's not okay now enough, but it's fun if you have ideas what to test with that. We can hook it up anytime and look at stuff. Soldering irons, LEDs. Oh, yesterday. No. There's no way I can build something like that. This is like, you need, what do you need? Like gallium? No. What's germanium or some stupidly expensive lens for that. And then you need like infrared detecting pixels and whatnot. There's no way you can do that easily. Okay, let's code. So, Paint, MS Paint for today's stream. We are half hour in. Enough introduction. Let's start with, yeah, not easily. Hardly. We can use like, if we can get like a lens. Wait a minute. We saw the infrared oh, this what is that on my eye here? There is something on my eye sticking there. Oh, this is annoying me. Okay, let's not look at me. Let's look at our desktop font. Where is the fondue here? Where is the fondue? Chat fondue. Here we go. Oh yeah, that's not that. What is this? CDC contest. Super cluster to do. Oh yeah, we stopped at a bad place last time. Okay, so okay, yeah, whatever. They can say no. I will use AI because it really helps getting started, and you might even see that today if it works. So, what, Parker? What is? Oh, thank you very much for the donation, super chat. Thank you, Parker Reed. You're new. At least I don't know your name yet, so maybe you're lurking for some time already to the live streams. Yeah. Thank you very much for the donation. So today, unfortunately, no LEDs. Oh, really? Oh, cool. That's great. Oh yeah. Okay. Nice. Yeah. I noticed like sometimes the streams are rewatched. I don't know, by like they get like almost the last one. Not the last one. Some of the last ones got like 700 views, and we have like 20 people's watching or 30 people's watching, while it's okay. Here we go. Here. This is my pitch for you today. This is a project that will go on for a little bit longer. If you know a shortcut, I will take it, most probably. But okay, we have a house, no? This is a house, and basically we can use the thermal camera and see. Oh yeah, this is like losing. We can see like really cold here. Everything is cold. This is losing all the heat. Losing all the heat. Okay. Shoot. One too many back. So we want to insulate with a like styrofoam or natural materials and insulate our homes. That's what we do. Okay, we put like a nice coat on the house. The house needs a nice coat, and we put like really good windows. Like we oh no, what is that? Is this like the insulation and this is left, all is left from the window? Yeah, apparently it seems like, okay, we can maybe widen the window a little bit, and this is like the thick frame, and this is like three drink. Here we go. So now it's really greatly insulated. We got some extra layer of insulation for. Nope, spider. Okay. Um, Here we go. Super thick insulated, and there are no leaks anymore. So there are no warm farts escaping the house, and this is basically the problem. All the farts are like they are caught inside of the house. Well, let's make them like this color. So this is like, okay. So they're all caught in this, enclosed in this home. And hey, Paulus, suggest a material. Okay, for cheap ones, I don't know, stone wool, rock wool is like a cheap alternative. If you want to do a fix and flip, you need to no, your volume should be fine. Should we be painting 3D for 3D coding? Not yet, not yet, not yet. We will algorithmically paint in 3D. However, the problem is like with the warm farts in there, and okay, everything is and we don't have like any exchange of. Okay, you want 3D? Okay, you get 3D. Okay, here is the house in 3D. Here we go. There is yeah, or like cheese and whatnot. Okay, so this is now in 3D. And the problem, what? It's coming out of the screen. Okay. Okay, so the good one, there's like there's a good alternative is like wood fiber insulation, which is ecologically quite well for your living environment because vacuum insulated panels, yeah. So wood fiber is cost unfortunately twice as much, and probably there is a shortage in getting that delivered in, at least in Germany right now. No, unfortunately it's not, because today we don't want to break anything, because I broke enough today. And we will be coding. It will be a nice coding session with 3D and AI and simulation. And let's test the cheese. Let's test the cheese. I will burn my tongue. I see that happening. So now, since we are keeping like the heat in the home, because of the good insulation and everything is like really airtight, you can't get asbestos here anymore. No, you won't get it. Like this old-fashioned glass wool that is like cancerous. Use maybe TPU AI accelerator. What? Okay, so our problem is now, you know, no, like this is like the starting situation. Now the problem is we want to get the farts out. Okay, farts need to go out. Let's draw, okay, this arrow. We want them out, but we want the oh, now unfortunately we want the farts when they are out to be cold and the warmth stays inside. Yeah, and we want the heat to stay in the home, okay? Stays here and the farts gets out and we get like warm. Oh, wait. Maybe we can draw it like that. So, no. Okay, so we have like fresh air. How do we draw fresh air? Okay. How do we draw fresh air? Or what does like fresh air look like? Roomba with heat vision. Nah, I'm too lazy. Yeah, we could. But I don't want a gas boiler because we want to heat at all if we just keep the warmth inside. Okay, so let's say, okay, let's just draw a cloud, which has a good similarity to the fart, but is a good, and we want that in here. We want that in, but it should be a warm cloud. So we want some sort of heat exchange. We want a heat exchange system. Maybe yeah, that's basically yeah, but I don't want to open windows all the time, and opening the window, okay, yeah, a heat pump does that, but let's check out. Okay, something like that where so this is our goal. This is why everything disappeared. This okay, this is a blurred a stupid example, but this is what we are looking for. We were looking for some sort of tube. Wait, heat exchange ventilation. Okay. Yeah, these are the stupid. Oh yeah, here we go. This is a good example. Okay, here we go. Ah. So since okay, so you want some sort of oh really? Okay. This is like and this is like built like a grid. So one side, so there is no connection between like this airflow and this airflow except the walls of this grid. That's basically like a grid. Maybe I can find an image. This is basically also one. Something that we want to build is this is something that we want to build. But I want to make it nicely sophisticated. So I don't want like a huge system. I want just a, oh, this is a good one. This is the thing that we want to do. Okay, so there is like a cycle, I think, and that one is like stupid. it just has a one fan. Yeah, this one. Yeah, it basically pumps like oscillates between intake, outtake, and every time it like pushes the air, the warm farts out, the warmth of the farts are like heating up this element, and then it changes the direction and it tries to get fresh air in, which is basically coming from the same farts that you just exhausted. Yeah, and yeah, and this is basically returning, like heating up the cold air, because this is like warmer than the cold air, and you can basically recover a portion of, depending on how fast you are moving the air, you can recover a portion of the heat back, even like with this passive design, except for the fan. So the benefits of this design here, you just need a one, like, what is the hole diameter? You just need to drill one hole in the wall, and you don't need like to do anything like super exceptional. You can just put it in any room, and you get a good ventilation and can preserve some of the heat. Okay, you need just a power supply for that one. Oh yeah, there is even, what is this, speed? Okay. And you just need to drill like I want 10 centimeters, 20 centimeters, whatever core drill that might be. But this is how it looks like. Can be easily installed even by yourself and by me, most probably, if you get like the tool to drill that you can probably land at your hardware store. But I want it a little bit better than that. So this is like pulsing. That might be annoying because you have like changing sound. Like that. Maybe like, I don't know, fan spin. Fan spin. Okay. So what I want to do is, this is my invention, patent pending. Patent pending. Okay, here we go. No, it's really working. It's really working. So what we want is like something like this heat exchange grid, like that. And we have, this is like 3D. Okay. Oh, yeah, that's badly drawn here. Let's say that this is our heating system. And what I want to do is, I want here cold air here, cold air here, and warm air here, sliced in between. And okay, we need a fourth one. Let's draw the fourth cavity here. Oh, yeah, that's bad. Okay, you can imagine what I was thinking here. Warm air here, and these walls in between, they're metal, and the heat is exchanging from this cold air, which is constantly flowing. We have a constant flow of this air and constant flow of this air. Now we want it more complicated than that. We want a grid. Okay, we want a grid like that. This is like the front view. Yeah, the car radiator is modeled to exchange heat between water and air, and we want air to air, which is basically like this grid. your only problem with that grid is you want, like, let's say if this is warm air flowing in one direction and you have like cold air, you want it next to it, so it has like the most contact. So obviously you want also like cold air here, cold air here, cold air here, and you want yeah, ChatGPT can like idea to working product. Okay, this is the thing. This is the thing that we want. So our goal, what we want to achieve, is doing that. Bucket fill tool? What bucket fill tool? What? Okay, here we go. This is what we are looking for. This is this part. Okay, if someone steals that from me, I will sue you and I will get half of your revenue. Z folds plate stack ridge to ridge. Yeah, but you need to weld it somehow. I mean, you can still like intersect plates or whatever. So PCB way can 3D print copper, aluminium. I think copper, they can copper. At least aluminium would be great because aluminium has a good heat transfer value, whatever that's like called. That is what we want to solve today. This is the issue. Okay, so let me draw. I'm still with the pitch. We have. Okay, so this is the middle section. This is the middle section. I'll tell you what I would, yeah, square aluminum. You can use square aluminum tubes. That is a thing maybe that we can do. But if we can print it and we can print it for free and can make a project out of that and upload it to YouTube, we can do it. The only problem, I mean, we should do it. So that this is my way to work. I will just 3D print it from one like one piece. Okay, this is like the middle section here. And now the challenge is that we want at the end to something happen like that. Something like that. This part and this part. This part, and then we can just draw something in between like that. So you can imagine there is like some convolution in here that's happening, and at the end, I don't care about the last part. The last part, yeah, that's that. Up. Foo. How do I change the color? Okay, here. This can be 3D printed. I don't care really. So this can be something like that. You can imagine this has to go on the other side as well. Oops, you can barely see that. The window is. I will just shift it. And then you will see like this is basically changing color. So at this point, this will be probably a cold fart going this direction. And this will be a nice like cold cloud coming in. And this will be a warm cloud coming out. Maybe even on the other side, you don't know. Warm, cold, yeah. We might want to flip it. I'm not sure yet. Warm cloud coming out here and warm fart going in here. Okay. And this is coming out. Is that so? Is that so? Is the area the same? I wouldn't say so. I think the area is smaller, the heat exchange area. You need like the area needs to be maximized compared to the volume, because you can control the volume with the flow rate, but you need like really good area connection to get the most out of the heat and not restrict the flow too much. So is that true that the area is the same? Because we have like the extra walls here. If the walls are gone, we lose this area here. Distance to the surface. Yes, ceramic, I don't know if that works. I don't know how a good of heat exchange value you get with ceramic. But I wanted to test the 3D printing, like SLA 3D printing, and this is a nice use case for that. But then we can stop coding now. Narrow slots. Okay. And we don't need to simulate anything, because my idea would be yeah, ChatGPT will lose. Here, this is what I wanted to simulate. Optimize. Ah. What came out? With slot? What? Dipped? What? Aluminium? Okay, so I wanted to do the following. I wanted to simulate a good channel distribution where there is like this, the heat and cold channel is split to as many channels that we need here, project here, and get like this convolution here. So we need just a volume of slices or let's say ropes. You can use rope simulation for that or whatever, to basically take those which are arranged in this grid here and take this here and then rearrange the ends of the rope. If you can imagine like that. I don't know if you can imagine that. Okay, imagine you have like, we need more space. Okay, I will try to do so. Okay, we have the cold area, and this is basically endpoints which can move around. I mean, this is a nice challenge, which can move around freely within that area, but are restricted to the endpoints here. Turbulent flow. Cannelloni? You guys are terrible. Developing stuff with you guys. I mean, you say, okay, we should use channels instead. Oh yeah, this is moving somewhere else. So, oops. This is moving like to the other side. So there will be channels in between that are basically moving to the other side. But this is like, there is a convolution. I think I made even some sketches. How you could, yeah, this is not the what. Let me check that. Because if you say so, heat exchange, oh no, I don't have to, where did I draw it? Metal, synth, heat exchange, what is this? What is the project name? Here. Okay. Okay, so we have the solution already. This is our, if we go with slots, we can basically make it like that. This will be enough. Just this windows. So my idea, like drawing it, like pixelating it hand by hand, would end up like this. Might have been one solution. This is like some sort of mapping. Okay, let's imagine these are the channels, and then I just checked. Okay, what area can we map? Can we go from this to this, and then go even rougher until we end like that? This is just pixelated. But now, if your opinion is, oh, we can totally do just slits, we have the solution here. This is basically all we need. Smooth flow, yeah, it's not really smooth with that, because you introduce walls where no walls have been. So the pressure here is way higher than here, probably twice as high, because you have like, there is like, I think, a certain resolution that you can only do. Dimple sheet, what is what? Okay, so We don't need to simulate anything, but we can still write a generator for this thing here, like for these slides. This is a cool design. I did it. I did it by hand. It's like an opening eye, and then generate a triangulation from that. Should we make it methodically and then try to generate a volume? The fins are basically the heat exchanger for hot water. Really? What is a... The only benefit of this here, it doesn't change the diameter. Usually you would have probably a pipe coming from the bottom and the top and joining slowly, like being sliced and then joining slowly, getting thicker. In that case, we are constricted like to this diameter. We have like to keep the diameter, and I think we should still simulate it. Generate a volume. A lot of tubes inside a big tube. Yeah. Because you can only drill circular. And you can use like, for the surrounding, you can already use like PVC pipes or whatever. So also it isn't like structurally square. There are square drill bits even. Oh, Jaco, that's good. That's a good thing. Where did you, Jaco, Jaco, or is it Jaco or Jacko? Is it Jif or... Jaco, okay, here we go. Not like Jif. Animated Jaco. Here we go. Oh, you're making my design completely obsolete. How do I upsell it on Punch Beginner? I mean Kickstarter. Did you know that I own the platform Punch Beginner? Which is a meme platform to Kickstarter. I at least own the domain. Oh, that's a town, Costa Rica. Okay, so let's okay. I need to save that. Not super krass, so. How you stream? You outsmart me. I'm thinking about this stupid problem for ages, and then you come along and... Yeah. We do science today. Okay, I stored that. Let's do new one. Ah, cool. Okay. So Jaco suggests we just take like regular copper or whatever pipes. Let's say we do half tube here, can be metal, plastic, whatever. Really? Well, soft problem. Oh no. Okay. Yeah, and then just drill holes and get the pipes sheared through that. And the other one is just the other half is just open, and you get basically the heat exchange on the pipes, and we can get we can just take off the shelf copper pipes. I have one here. Let me grab the pipes here. Where's my copper pipes? Oh, here are some. Okay. Stupid headphone disconnected. Here we go. So we can just take even like thinner ones like this here. We can take that and basically put it through that and just close. Humidity, it's copper or aluminum. It doesn't mold or anything. Oh shit. Maybe we need a drip edge. Foo. Yeah, reinventing the wheel. That's me. That sounds like me. Okay, to rejoin. Okay, so thick copper pipe. That's like basic tubing from like whatever. This is too thick. Not much heat exchange. Here, we can get aluminum and copper pipes. But I get the 3D printing, 3D SLA. I want to do something SLA printed, and this would be one thing, a good use case that I can. Oh, this is too cold. Hey, Mr. Who. Brass. Yeah. I think this is copper. This might be copper. Or is it brass? I don't know. No, this is copper. It looks brass to me. Okay, it's brass. You keep it. You keep it. The brass. Oh, foo. And this here? This is copper. This is copper. Okay. Wait! Is there a color difference? Because I can see that. Oh man, it's probably green. What is the color difference here? I'm colorblind, you know that. Please help me. What is the difference in color? Is this greenish? And this is more like reddish, or what is the color? Oxide is blue. There is no, brass is more gold. And is there like, is copper brown? Red brown? Won't alu corrode like crazy in contact? Alu in contact with alu? I don't think so. Contact with copper. No, I don't want to I don't want to like combine different materials. Okay, the solution. This is good. The solution for okay. Recommendation: installing it at a slight angle to the outside so it gets a drip edge there. Tarnished yellow and dark brown with copper green. Green, yeah. That's the problem. I can see green very well. Okay, you drill just at a slight angle and there will be a drip edge. Are you satisfied? Oh, it's snowing outside. Yeah. Why should we buy it if we can get it laser sintered? Let's check. This is so evil. Like JC PCB plays ads on the keyword PCB way, so they get on top of the recommendations by Google. Metal sheet, we can do that. SLA, 3D printing. What is the, okay, millimeter quantity? Is there like, oh no. So what is the material that we want? Wait, this is not, it's not metal printing. Is this metal? Aluminium, PETG, stainless steel, titanium, tool steel. Now, titanium, does it have like good heat exchange? No. Okay, we need to take aluminium then. We don't take stainless steel, would be good against the corrosion. What is that? Oh, we can do a surface finish on that. No options. Discrepancy warning. Show material description. It gets even like a rough surface for a good thermal exchange. Material data sheet. Unobtained. And then print it and get it sponsored. I want it made from solid gold. Oh. There is a picture of me on Twitter holding that in my hand. There's a picture of me on Twitter holding that in my hand. Shit. Can I find it? I had to post so much. Okay, I can find it, but it's there. Oh, density. Where is the resolution that we can print? So we get resources capabilities. Let's say this is stereolithography. Is this LAA SLM? No, this is SL. Ah, shit, that's the wrong one. Product SL. Oh, foo. Sheet. No, aluminium. SLM. This is SLM. Okay. So printed printed 3D prints. Huh? Product capabilities. Not PCB, PCBA. Nah, that's not what I'm looking for. Where is my capabilities here? Capabilities SLM here. And what I'm looking for. Okay, drawbacks, blah, blah, blah. 30 millimeters diameter. Our tube. 30, yeah. 30 centimeters, sorry. SLS. Minimum wall thickness is 1 millimeter. So these are our limitations for our design. Yeah. No, we don't need to do it like this thick. I would check for a default vent size. So we can test that, but the depth is okay. I mean, we can do like a full print. You can almost escape. Imagine we print that and test it with the thermal camera. Wouldn't that be cool? Isn't that like a cool, fun project? It doesn't need to be like meaningful. It just needs to be good to look at. I'm still a YouTube maker. Okay, where's the 3D coding? Back to the roots. Where's the other? Oh, we saved the other one. Okay, whatever. Okay, this is distracting me. Go away. We wasted already 1.5 hours without writing a line of code. Okay, let's start. Let's start with, where's our file? Heat exchange. We don't need to save that. Okay. Oh, wait. We had the other one also open. We want to emulate that, and then we want to generate geometry or a volume. If we can like use marching squares or whatever to... Look at this, I have olives. Marching squares to get the volume of the resulting Venturi. What is Venturi? Venturi. What is Venturi? Do you want to make a jet or what? A cone? But I don't know. I can't imagine what you want me to do. A funnel. Okay. A But how do we funnel this? What do you mean? I don't get the way you want me to do that. I can get some tea meanwhile. So I take your advice because this is hard to solve. Like the transition from lines or solid to squares is a hard problem. I wanted to simulate it because I was too lazy to think how to continue with this convolution here. So the problem here was, okay, I wanted to take it from this step here and just shift them against each other, so we get this grid like that, and there are basically some of the but why do we want to have something like that? But why do we want that? I still don't get like the problem that we solve. Do it in Minecraft. Yes. Tag with Benuli, the sidekick. Cone detective. Okay, shall we code something? Okay, let's get ChatGPT and start the coding. I didn't write AI in my description of the stream. We should add this first. Where is that? Foo out. Our Oh really? Why is my stream live stats showing that I have only 2 viewers right now? What? Oh shit. This is bad. Okay. Edit, and I add just AI. Okay. Okay. Yeah, okay. Yeah, that's my stats are broken. ChatGPT. Let's open that. Yeah, nice. Okay. If only, huh? Okay, here we go. Right. An HTML JS page that renders a 2D array, a 2D generated array to a canvas okay, yes, let's start with that. Okay. While I'm still eating, it will write the code. Them will write the code. Where's my I need more. I will create the file meanwhile. And if you adopters of okay, let's see generator HTML. Okay. Let's copy that code. Add this here and run it. Okay, it draws something. What? Okay, so let's see what it does. Okay, it has an array that fills it with random colors. And then just generates the canvas. Okay, then let's what? Why, Chris? Let's see how we can get starting point here. This is just our starting point. We will continue from that and improve it and write the actual simulation, because I don't really want to do that. We'll just, okay, add a button to save the canvas content to a JPEG file. Here we go. That's what we want. It's just a tool. It's just like Copilot on steroids. Okay, let's test it without even looking. Okay, that works. Easy, huh? Now, shall we continue with, this is like a good starting point. I don't know about you, but basically, this is what ChatGPT is made for. Just save you like half an hour of headache to find out again, like, oh, I need a starting point where to begin. This is easy. The only stupid thing is, I probably used fill rec. Yeah, that's stupid. Okay, let's change that. Use 1 pixel for each array element. Let's see if it changes the method of drawing. Yeah, that would be really stupid. Why would you do that? It's probably only when like stupid old farts are ruling the country, if something like that happens. How I mean, AI can't be stopped, especially if it's like a useful tool like that here. Here we go, data URL. Wait, this is called fillrect. It still uses fillrect. Can you use set pixel? No, what is the data? Canvas. No. Put image data, okay. Put image data instead of fill rect. Hex to RGB, interesting. Hey Rota. Oh, I lost my bread in there. Oh wait, you can see the fondue. The fondue is the best part today. I lost it, the bread. Here it is. I ate a lot already. Okay, let's copy the code. Yeah, that seems like put image data. That's actually what I wanted. Okay, let's go. Let's test that. My nephew. Ah, nice. Okay, that's cool. Look at that. It's 10 by 10. Let's change it to be 500 by 500. I don't know if... let's check again. Oh, still working. Okay, nice. Check the image. Come on. Okay, here we go. Okay, great. So, minimal wall thickness is 1 millimeter. A non-cam foot magically appears. Yeah. I'm almost done with the bread. Maybe I just finish the cheese part for today, because I don't have much bread. You can see that. Ah! No, the bunny. Oh, not my speakers. Bread is almost done. Okay, this is working. Now, nice noise. What is that? That's the first slice of our volume of the 3D print that we want to generate. Okay, let's generate the first slice of our thing here. Okay, so we have 1 millimeter resolution of the walls in between. I don't know what thickness do we want to go for. Hey, Michael. So the wall thickness is basically here in between. So we want, I think we want the channels to be at least 2 millimeters, because I think otherwise we might get problems with the 3D print at the end. It will be just blobby and leaky and whatnot. Okay, so let's define some constants. Const slice air. No, we're using SLM printing. We want to use, what printing method do we want to use? Where is it? PCB waste, aluminium, whatnot thing. And now we want just to generate a volume and maybe a triangulation out of that later. So slice air will be 2 millimeters. We are only using millimeters here as, and slice wall will be 1 millimeter, 1 pixel. I mean, we can just use integers as well. Yeah, we can use titanium. RNG hates this one simple trick. Huh? Okay, slice wall. Then const radius will be not radius, diameter. Diameter will be what is like the quadrille typical. No, let me oh wait, let's check with that one here, that design. What's the diameter here? We have like this example design. What's the diameter here? Where's the diameter? I hope it's not like inches here. Come on, what is solo characteristics? Frequency. Kidding me. Duct. Okay, let's just assume we get like 10 centimeters. Okay, so let's do diameter 100. That will be all we need. Okay, diameter, then const radius will be and then center x will be basically diameter. Oh no, it's basically radius, huh? And center y will be also radius. We can change that. Y. And then we will do rows calls as basically diameter. And then we will generate, yeah, we don't need color, push color. We just do, we can generate black or white. There, let's use, we can just use 1 and 0 here. Or do we want like IDs? Okay, let's do const air. Material air will be 0. Wait, which air is it? No! Material vacuum. Yeah, but it's probably not valuable. The diamond. Okay, so you check out the best material that I can use for heat transfer. Now I'm warm again, with all the cheese in my veins. It's my NASA T-shirt, by the way. I got it for birthday at some point. Okay. Material in air in. So we have like different materials, and then we get a material wall. Wall is 3, okay? So we got here, okay. Now, oh, it uses rows and calls. We want X and Y in that case, okay? Okay, let's start with X and Y. Are you cringing for me using Notepad++ with white background? Wait, let's do it YRes and X or XRes, YRes. Basically diameter. Let me use that. We can move it here, and center will be not radius. We will XRes times 0.5 and YRes. If we decide to get like a volume with a margin, we can use that and do XRes and YRes something different than that. Okay, we can just add. We can just add +2 here and +2. Let's do that. Okay, and then let's start with Y here. Hey Brian, did you see the pictures? Did Tony send them to you? I told her, like you told me, oh, you don't need a jacket today. Oh, I didn't even say that. I showed the pictures and the video already at the beginning of the stream. Of also doxing the license plate number. Okay, let's do diamond, and this will be material number 69. Yeah, to get stuck on a thing like that, and then I am completely soaked. Oh, you mean I am the best? Oh no, you mother. YRes and Y++, and then we have some X. We'll just put everything in one array here. X. Yeah. Or cars are the common factor here. In both cases, the trouble starts with the car misbehaving. Or you cursed me. You just gave me the curse. I need to pass it to someone else. I passed it now to Tony. But because she was sitting on the shotgun. White cars. Is he a white? I don't. Yeah. Okay. Let D be that car is so small you won't be able. Okay. X minus, or let's do center X minus X. Ah, papa. Now I need Copilot to be faster. Some people hate. So okay, dx, 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 dy, dy. Okay, Pythagoras for you. That's the distance, and the distance. Let's let mud be vacuum. So this is the vacuum. $50. Yeah. My mom died, but my dad, I will not spoil. I don't remember even the address, so I can dox him. Okay, that's the last of the cheese for today. I can turn it off because I suffocate here with this smelly cheese. Okay, if D is shorter than radius, okay, we make it from solid diamond, okay? Shorter equal or equal? No. Let's do it equal. Let's start with that. Then mud equals material diamond and push mud. And then let's do what, Doctor? Was it a storm or what? Ah, okay. So how do we do mud colors? Okay, we do const mud colors. All right. So we take diamond. Diamond will be what color is a diamond? Is it white? It is a bluish white. What color? What color is diamond? Okay, color of diamond. Oh, there are different ones. Foo. Okay, let's ask ChatGPT because we are working. Okay, it's just white. It make it just pink diamond. Okay, give me RGB for pink. Baby pink, light pink, hot pink, fuchsia, rose pink, bubblegum pink. Which one do you like? Johnny, it's you paid for the pink last time. You can pick the light pink. Okay, here we go. So diamonds are light pink now, my friends. This is what we code. Colors and vacuum will be basically 0, 0, 0, including A. So we have like this is. Oh wait, we're storing JPEG. We need to do like PNG. Okay, whatever. We will change that. I think that's not. Okay, air in is cold and air out. Air in. Come on. This is stupid. I need to switch to code, which will be, let's say light bluish. Let's say 64, 255, 55, and out will be hot, the hot farts out, which will basically 255. Let's make it a little bit more yellowish than bluish, and let's put 16 here. That's out, and the wall will be RGB for aluminium. What? This is just gray. Okay, let's take it. Air out, and gray wall. Okay, this is that. Now we need to change image PNG, save button and PNG, body append child. Where does it, how does it store it? Canvas to data URL, it really does, whoa, that's cool. Okay, yeah, that's changed. Now we need do color, const color, which is basically, I don't care. I don't care that. X res y res, and we need to the x res y res and create image data x res and y res, and now we will do arc. So let color, let's see, is everyone want to know what matte colors, and then we just take matte colors off, and yeah, whatever. Let's take colors. I picks. Okay. And that's not random colors anymore. 2D array. Yeah, it's not 2D, it's like 1D, but okay. Picks, and then I, which is all right. We have a sequential array here, and then we need C, zero. Okay, are we done here? Are we finished? If so, I can get some olives. Nope, it failed. Okay, 12. Let's see what happened. Do we have? Is there like console math? Square root. Okay, here we go. Typo. What is this? Cannot reproduce undefined. Reading where? Is this like colors? C0. Wait, what? Undefined. Matte colors pix I. Oh, let me check that. What is pix I? All right. What is I? I is 0. Pix. Wait. Foo. foo off with this message here. I don't need you. Okay, pick 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, Oh no, is this? It took the name. Okay, let's do it. Ah, shoot. How do we? Okay, in this case, I really understand why JavaScript should use either like quotes here or not or interpret it. Oh, foo. Let me check something. Yeah, eval doesn't like unexpected token. That doesn't work. Shit. Okay, we let's just hard code it then. Whatever. I don't know how to solve that without being like stupid. We don't have sequential. Okay, I think this should run. Okay, this is our solid pink diamond diamond tube. Do you want to that stored? Ah, the PNG worked even with the transparency in the back. Cool. That was easy. Okay, Johnny, you get that. This is like your NFT here, or FT, whatever you like. What is this? Type. What? Where is this downloaded? Huh? Where did it download? I don't see it. Huh? Where's this downloaded to? Okay, here it is. It is in downloads, but it didn't show properly. Okay, Johnny. Oh, I don't have Discord open. Okay, where's Johnny Bergdahl here? Johnny. Here we go. Anyone else wants this image? Okay. Yeah. Bitluni fungible token. Okay, I can. Now this is special. This one is special. It's only. I mean, you can still generate it yourself, and it won't be distinguishable, but I do it only for Johnny in this case. Anyone else special needs here? Okay, let's go. Okay, now we want a wall thickness, outer wall thickness of 2. Should we do this like outer wall diameter or const slice wall outer will be also 2 millimeters. Okay, so it's a little bit more solid. So so if D is radius, if D is smaller than radius and D is bigger than radius, wow, okay, we need to switch to code. Minus slice wall diameter. Here we go. Now we have the 2 millimeters diameter. It's cool, generated. Should we zoom it in? We can edit, add a zoom. Is it border canvas, border zoom? Easy. Zoom times 4. Here we go. Maybe we need to turn off the filtering. How do we do? How to turn off? Oh, how to do pixelated filtering in CSS. Image rendering pixelated. Oh no, wait, that's not what I want. Image and image scaling nearest neighbor. Okay, I don't know how to spell neighbor here. Pixelated image render. It's still crisp images, property to crisp. Mods webkit, crisp images, image range pixelated. Oh, interesting, crisp image. Okay, let's try that. I want a crisp image. Okay, whoo, yes, here we go. Oh, crisp, that's cool. I like it, okay. Can we do it? Let's try what the difference is. I don't think that works. I think we might need to use comment like that in CSS. No, that works. Pixelated was the right thing. It did know what I want to. Okay. Let's do 6 times. So, okay, this is good. So we have some debugging capabilities. Now we can see some slices. Tech, what is? Might be better in the wind. Okay, I deserve now a few olives before I start eating the sweets. Olives. I feel so healthy now. Okay, let's generate some slices here, okay? We get can we calculate when does this pixels or this is stupid here. These pixels are stupid. Basically, okay. Let's make it equal. Okay, so yeah, let's close it like that. It's better because it's barely excluded. Now you want here like to have a curtain. What are you talking? I lost track of what you're talking about. I need to switch that because that one needs to recharge. Oh, now I switched the ears for you, so I basically don't know what you're talking about anymore. Okay, this is like a square root or something, huh? Rendering. How do we render? Because we want like half of that to be blue and the other half to be red. Okay, so let's start. If D is smaller than that, let's do inner part. Okay, and now let's switch to Visual Studio to code. Let's open that generator with code. Okay, so we get some. If some stupid plugin annoys me with some updates right now, I will kill it. Okay, nothing popped up. I hate it. I hate it when restricted. Wow, what? Restricted mode? Save. What do you want from me? F you. I don't want pop-ups. I don't want messages. I just want to work. Here we go. Now I have to. Now, if you're using OLED display, you're saving energy with this dark display. Okay, inner part. Let's do if. Oh, where do we split? Oh, this is interesting. If y is shorter than y center y, then mod equals material error in. Let's do that. And else mod equals material error out. Okay, here, this is our generator. Boop, finished. Let's go. But is it? I think we might have like a short discrepancy. Oh, I see also a problem. Where is the center? Where is the center? The center should be plus half of it. We can see that already here. Okay, this is like diameter center minus 0.5 because we want it really to be centered. So we need to do like subpixels. Here we go. Oof, that shifted. Okay, this shifted. We have a diamond outer wall. And now we have that, but we need to scale. We need to scale that here. Like we need to add a face. What happened? Did I disconnect from the chat? Oh no, what happened? I can't hear anything. Oh, I lost a lot of chat. Foo. Okay. Hey, Christian. Okay, here we go. Yeah, maybe. Now we need something like a phase because we want to generate. Okay, here is store, blah blah blah, and we need like to generate. Let's start with a phase, and the phase will be between const phase will be 0, and this will be 0 to 1. Okay, let's say 0.0 to 1.0, and we determine like this is like the initial state at phase 0, and the state that we want it to be. So let's say stupidly phase 0, then this is like the start of our volume, like the first slice. We can also just say it's z. Okay, if z, we can use slices. Okay, then const how many transition depth or transition depth. Okay, that will be like how many slices this will be. How many millimeters do we want for the transition? I would say something like that. Maybe 8. 8 is a good number. Whoop. So 8 centimeters will be 80 slices. Transition depth, and basically we have 0. This is slice 0. So if z is that, then this is our, and if z is transition depth minus 1, then we want basically something else. So we want to, oh, sorry. Thanks. Mic mute? What? Let's see. Yeah, I muted it with my hand. Yeah, I wasn't fast enough. It was, thank you. Okay, here we go. COVID, here we go. You get digital COVID. Do we have the virus emoji? Do I have the virus emoji? There's a virus. I don't know if there is emoji. No, there is no emoji. Virus. Ah, shit. Foo. If you find one, you keep it. This is the cold I caught today while waiting for the emergency truck. Okay, I don't see. Okay, whatever. Concentration of. Okay, if. So what's our deal? If x and 1, else that. This is the, okay. So let's do z1 and then check if it's still working. This is the one. Nope, it doesn't. Wait. Oh, yeah, we need to do that z. Sorry. Okay. No, this is not what we want. We have like specs for that. COVID here will come. Appa. Generator. I have too many windows open. Okay. Now we need like alternating pattern between slice air and slice wall. That's like, okay, so we need const. What's in the center? It's a wall. In the center there should be a wall. Microbe. Why don't... Okay, yeah, no, microbe. Oh, yeah, that's the one. Cool. So we have like slice wall air. Air will be basically, so slice air plus slice wall, and then we will use dx. Dx is like okay, here dx modulo slice wall air. That's like reminder is let R be that, and if R equals 0, and now we also need let block me. What is this? How do we call it? How many? Let's call it just D. I don't care. No, we have D already. Let's just call. I don't care. Okay, and we need dx divided by slice wall air, and that will be math floor. If that works, because we have a negative thingy there. Equals 0, then we have mat will be material wall, and if R and else if A and 1, we have material will be equal to, what is it, material in whatever, in else we can do even like a simulation of like the heat transfer, and that's so. Why is that? Why did that happen here? And why is there like a slight head? That shouldn't be even possible. Okay, what did we divide? And where's the wall? 0 dx really? Ah! Oh, oh, I get like a cloudy vision when I look at it. Ah, but where's the wall? What happened to the wall? Where's the reminder here? Where? Hmm. In, out, else equals, what is? Oh, it's always like, oh, it's 0.5 and stuff. Uh, so below 1, is that what? Oh, ouch. Oh, really? Okay. I try to. Oh, oh, I got it. Ah, slice wall air. This is also missing here. This is wrong. Okay. Okay. All right. Now we need to do it like that. dx abs dx. In that case, let's see now. This is stupid because we get now stupid, and I should feel bad, and this is shoot, doesn't. Oh, oh no. I hate absolute values here. Let me check something. Shorter equal. No, there was nothing. Okay. You know what we do? We do something really stupid. Please don't look. That's a bloody hack. That's a let 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 the dx bloody hack be just dx plus x res, I don't know, times slice wall air bloody hack, but it will work. Famous last words, huh? Kneel before me, the master of the bloody hackery. Oh no, but we have like an not really well. Okay. I still don't get why the zoom gets us like this step here. Do you see that? Now it's gone. If I zoom, now it appears. Now it's gone again. it's like a graphics card problem or of some sort. Or save as JPEG. I need to rename that as well. That's not save as JPEG mehr. Save as PNG. Okay, here we go. Okay, I still like it though. I'm not sure if it's like, I mean, there is no actual center here because we still need like this wall. 3D coding. Because you lack imagination, my friend. This is only one slice of a 3D volume that we are generating right now. Do you see that? Yeah, but we can generate either, we can store a volume and get like a slider with Z. Oh, we can do that. That is easy. But I need really to pee really hard, so I'll be back in a second. How do I not smell that? This is terrible, this cheese. Oh, I need to ban this from my lab right now. Oof. Let me get the fondue away from here. This is horrible. The smell is like really bad. Whew. Here we go. Oh man, the smell of the cheese. Once I left the room and then went back. What did I miss? Extrude, dude. Extrude. Okay. You know what? Why I was upstairs, I noticed, I mean, the wall is always at least 1 pixel. We might, because now we need like to do this transition, which will be harder and harder to calculate, we might just want to generate the blue and red and then just do all the pixels between on the transition from blue to red. We should just change to the aluminium. So always like the border, so we have exact 1 pixel that's going around around that, and the perfect transition. So we don't need to think about like corners right now. But let's just think for once. This looks terrible here. I will just put it on the desk, and now you will get bad audio here on my mug. I will put it on my mug. Okay. when I drink my tea, you get better audio. Oh, wow, the smell. It's horrible. Okay, now we have some sweets left only here. The hot plate can. Oh, yeah, by the way, this, I got this for, also for Easter. I love that. Do you know that? It's like a, you know, Turkish honey sometimes called, or soft nougat. Tea mic stand, yeah, that's. And here, yeah, this is like Nom's still nougat. Oh, now I need to open it already. That's basically sugar and pistachio or something. Pure sugar. And I didn't do sports today. Uh-oh. My spots were shaking in the cold rain today. Okay. Now it's back to the job. We still need to do 3D today. Let's go. Oh, this is great. Brain needs sugar. And I need a lot of sugar, huh? With the level of thinking that I'm doing. Okay. Let me try something else. Now, let's do, let's go just 40 here. Layer 40. There's nothing. Let's generate an eye here, okay? And then we will just conclude everything in one neat code at the end, okay? What is that? Isn't there a closing bracket, a proper? Oh, this nougat is so great. It's so soft also. Unfortunately, it sticks really to this plastic. Need more tea from my tea stand. By the way, all the Brits will hate me because I'm drinking Earl Grey. This is not Yorkshire or whatever. Yorkshire tea. It's spiffing Brit drinks. Black tea is just. See shenanigans? It's alright, we are getting there. It might not be the Charles Lohr level of 3D today. We just need to generate a volume and maybe triangulate it, and at least I planned for it, but we are already like 2.5 hours in the stream. We have 1.5 hour left. If I really, maybe I will do a little bit longer today. Not longer than 2 o'clock, so 6 hours stream. So the value square root of, shit, I have not to think. Let me just calculate. Okay, we have r so x square plus y square equals r. Now we square that minus, we need the y value here. Do we need y? Yes. So r2 minus x2, and that squared is y. Okay, let's try that. So let's say y0 equals, and that's basically, I think this is the x and the y. Yeah. Math square root and the x plus, and we need the radius. Yeah. Radius, okay. We always can. This still can be a finite element method by simulating the heat transfer. We are not done, my friends. Okay, y0. Fy I just want to try something. Center y minus y0 and y is plus, and then do material. Okay, and now we need also, we are still within the radius, which is all right. Okay. .5. The eye of the beholder, my friend. Whoopala. Oh no, that's wrong. What did we do? This is not what we wanted. This is wrong. Baseball. Okay, let me think about it. Let me. Oh, that's minus. Okay. Yeah, 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 yeah. Oh, that's minus. Ouch. It's R minus. Yes. Sorry. That's what I wanted. Okay, here's the eye of the beholder. So, what? I need to scrub off that extra. Oh, yeah. It comes off. That extra nougat. I ate the whole thing. It was a bar of 100 grams. More or less pure sugar. I'll be up until 4 o'clock in the morning. Okay. So, now we need to think about what's happening here. Okay, we have a phase. This should be not calculated in the inner loop, but whatever. Oh no! CNC would be terrible. Like CNC off my finger or something, huh? Oh, I better close the window. I think my neighbors will hear me laughing out loud, and the cheese is already gone. I don't think the cheese smell is gone, but at least for the most part, the suffocating concentration is gone. Okay, this is basically phase one is the z, like transition depth minus one is so okay, here we go. Or should we? My last image could be still divided by transition depth. I mean, we can still let it end at so we, but I don't know if I want this. I mean, it continues with something else after that. No, that this is where he submitted to PCB way. Smell catalytic converter. Yeah, the smell is going out, but the fumes of the schnapps are staying in. No. Okay, so we have the phase, and now we need to basically phase. Okay, phase. Okay, and now we need a slider. Okay, let's add a slider. So we have this is the style, the button. Let's do inputs ID. Do we need ID? Yeah, no, I don't care about IDs here. Input type range min max, yeah, 100. much? No, 80. What is 80? 80 is, let's assume 80. And then on change. Oh, no, on input. Way better. Who dropped out? It wasn't me, was it? I hope not. It was me. Huh? No. Connected TT? No. It's me with the other ones? No. Okay. Not you, not bitluni. Okay. Okay, so let's do, that's not a const, that's a var. Z is now var, okay? Let's do Z is now var. And then let's do Z. On input event or this value, whatever. This value, and then we should redraw, which basically calls, wait a minute, that's not, oh, okay. Let's do head, body, onload, render. And that's basically that here. Function render put image, save button. We don't need that. Okay. I think we need to still push it one in. Yeah, here. That's huge function, huh? Okay, render. Now we need also to render. That's what's happening. Okay. Oh shit. Okay, yeah, let's BR here. BR. Up. Yeah, I don't care. I want to reinvent the wheel. Don't you know me? My friend, don't you know me? Okay, max value should be one shorter, 79. If only. Okay, here we go. Okay, that's 50. That's the start, and this will be the end. Okay, this is our goal. We have a slider. We can now store every single of the images, but we can store a complete volume if we like to, okay? We can also render var render z x z. So, and then we have z here, and we have render 0 here, because here we go. What are wheels? What wheels? What wheels do you mean? What? Okay, now interesting part is okay. Else, much better. Yeah, tell that my wheels, they didn't work today when I wanted them to work. Okay, this is what's our goal is. Now we need these sticks to go like and here, and this one and here. Okay, so we need to determine, are we in the area of this one or this one? Okay, so let's do that. So inner part, let's do let it be whatever. We don't need that. Shorter than central. Oh, let's okay, we don't need that. We do only else, okay? We don't only we do only else. We just reduce the cases here and we combine them. So we need like some logic to make this like this phase, the transition here nice, okay? We need that. Okay, so we have material air, material wall, and so on and so forth. Okay, so this is one material. And we have this phase, we calculate that y0, which is like some sort of distance. Okay, and now if y let's just I don't want to think that I will just do it like that. Else material is out. Okay, no thinking so far. We can just flip it minus, and then we will use this part. It's shorter than plus, and on this side. Okay, so that will, we try to conserve the space. Okay, conserve the space. It's basically the in and out volume should always be the same of the slice. Else, and whatnot. Wait. And one else. Okay. Something like that. Okay, this is now interesting. Now we have something, except we need like a wall here, but we don't need those walls. Okay, so these are like, this is like the end thing here. So what we will do now is we will remove basically all the walls here and A of Sauron. Whoop. Yeah. Graphics. That's computer graphics for you, my friend. And now we will do the trick with like post-processing. Or, no. Yeah, we do a second pass. Second pass will be easier. So we will just make every pixel that's like between those, we will make it different color, okay? So let's remove that here. Okay, let's try. Okay. Wait a minute. Yeah, there's no wall in between, but okay, that's flipped. Okay, that's flipped. So we got it wrong. Oh no. Out. In. In. Uh, heat transfer equation is quite simple. Um I mean we make it speak. What? Okay, now we have the smooth transition. The wall is missing, so we need a second pass, and now the second pass happens here. We'll just let it go, let it go. Pity, 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 pity. Okay, here we go. Second pass is coming for you. No, wait, that's the no, yeah, that's the second. Whoa, 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 whoa. Yeah, it's dubstep visualizer. Whoa, 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 whoa. Okay, let P or I as index. We need that plus y times x res because we have only a linear array. We're not pushing here, I. And now we don't need all the math, my friend. We just take pix, pix, pix. And we don't start at 0. We start at 1 here now. Wait. Wait a second. Wait a second. Who are you? I'm a meme lord. Come on. Here we go. -1. Because we want to like check left and right and so on. And there will be no transition. Voxel. Yeah, voxel void pixel. Here we go. Oh, this is terrible. Okay. Let me get function shit. Yeah, I call it P. F this X and Y. Let's do it, friends. And then we get the pix value, pix return. Oh, return pix value of x plus y times x res. I don't want. Yeah, it seems so, huh? Okay. I mean, we don't need that I if we have. Wait a minute. Yeah, but it's really hacky. Nobody will understand it again. Nobody will understand it. Okay, let's do it right. Yeah, I get when I'm excited, I get like, oh, I'm heating up right now. I feel like my body's already heating up. Sugar rush. I'm on fire. We will do some finite element method here. Maybe implement a shader or something for 3D volume visualization. Okay, I equals, oh, if, no, yes, if. Boop, 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 boop. Oh, sorry. Oh, man, this is terrible. Maybe we should redefine air and vacuum, air in and air out. No, wait, that's basically, we can use that, the bits. Oh, that's cool. We can combine those, okay? My friends, you will be wondering what the F is happening here. Pix I. Oh shoot, we need new pix. Pix 2. Oh no. Oh no, let pix 2 because we need like a new array, unfortunately, because we will change the array while we are reading it, and that shouldn't happen, so we will just redefine the array, whatever. Do it like that. Second pass, pigs to, wait, this is pigs to let, pigs to push, pigs to, what? Who's leaving? Oh, good night, Tech. Push pigs I. This is what happens if everything is right. If equals 3. Oh, wait. And 3 equals 3. Then else, else pigs to push material wall. Okay, here we go. And now we need this thing. Yeah. Pigs I. We only need to check maybe the direct now. Okay, let's try one first. -1 or pigs I or pigs I minus x res, okay? Then we probably need to go the full length here. Okay, that's that. And there's this magic number happening here, and we need to, okay, whatever. Let's do pigs equals pigs 2. Here we go, second pass is done. Oh no. What happened here? Eh? What did I do? Pigs push, pigs 2 push. Oh, wait, yeah, that's not working. Shit. If, okay, if x and y is else chocolate, yeah, chocolate is good. Okay, so let's do it like that. We need like the proper, but still broken. I don't know what happened here. Why is it? Why? What did I change? Okay, let me. Not that I changed something. This is still worky. This not worky. Wait. X-res, Y-res. No. Oh, let me check that. Let me check codes. Oh, there is an error. Where is it? I not defined. Oh yeah, true. I needs to be here. The border is not defined. Here we go. Whoop. Okay, so we don't change anything at the border, and the border needs to be calculated here. What else? Assigned to constant where? Oh, that's a variable constant. You know, let's do let. Okay. Oh, interesting. Okay, we have one bug here. Oh yeah, that was 0. Oh, look at that. Do you see the wall? Okay, there is still like issues like this here, this corner edges and this here. So let's basically do what I thought we should do. And that will be up. And also we should start at 0 as well. So min, max, I think value equals 0. So we, okay, yeah. And now I will explain what happens here in a second. Okay, my friends, all the magic numbers, nobody need. I don't know why this is here, but whatever. And 1. I think we can do. Yeah, so this will be still all right. Oh, what? Oh no. Wait, what? Isn't that? And 1? Okay, yeah, whatever. Whatever rose my boat here. Okay, still we keep that magic number here. Now I need only and x is shorter than x res minus 2. No, minus 1. And that's basically the last number, and y res. Okay, so we stay away from the border. That works. Now we also need to or. Oh, and by the way, we need to get this, and we need to or everything first and then end it. X res plus x, and this is why we and fix. Yeah, it's quite easy. You know the formula that we used here? Oh, that's now doubled. Doubled up is no good. But now we have like, it's the eye of ChatGPT. That's too thick. How do we do it? How do we do it properly? It works in X and Y, but here we get, yeah, they basically cancel each other. Oh no. So we need a special case. Okay, I explain what this magic number basically means. Look at our values. The material air in and air out are basically 1 and 2, which are basically 2 different bits in integer values. No, this is not what I wanted. I will fix that. No worries. I don't know why we still have like, but let me check for. Oh yes, I know what this diamond is. Oh shoot. Yeah, okay. That's what's happening here. Okay. So we want a different bit for, unfortunately, I need to change diamond from 69. Okay. Here, this will be, didn't help. Well, I didn't store. Upsala. Oh yeah, I need the colors here. 4 and 8. Okay. So what I'm just checking is, okay, this is fixed. 69 is basically, yeah. What I'm doing here is for each pixel, I check the pixel left to it, which is -1. Oh wait, this is +1. That's why we don't see thick walls here. Now we should always, yeah, next to it, to the right, and this is the pixel in the center. Then the pixel up, so -1 row of indices and 1 row down. And we basically use OR of all that values. And if in that case they are not either all the value of 2 or the second bit or the first bit, but we have both somewhere like one pixel is maybe in and the other's out, then we get like both bits set with and we see, oh yeah, there is like, in that case, there are next to this pixel there are different pixels of in and out. Oh, I'm stuck now. Now I choke on my sugar in my brain. Okay, so it's just taking OR of all the pixels surrounding and including the one, and then checking if there are two different pixels in and out. If so, then change it to wall. But in that case, we change too much. Let's draw. Hood. Neighborhood. Ah, yeah, neighborhood. Okay. So the problem is now we have our matrix is now like that. Okay. We check. Okay, we don't check that. We check this, and this. And the problem is before we got case. Oh, we can fix the case. So if we color, if we change from here to here, then this will change the color, but also this will change the color because there might be, no wait. This won't change the color and this one will change the color if there's the difference between here and here. So this is stupid to look in that direction, so we need to fix it. But then we had also like this case of a thin wall, but we don't want that, so we just use like this lookup, which will be minus 1. Okay, -1 and not +1 here. That will be 4. One less pixel to check. And let's see. Oh yes, this is working. This is what we want. There's always one wall thickness everywhere in between those faces. Nice. You don't need to code anything except for JavaScript and ChatGPT to get this into this point already. And these are basically our slices of our vent. Oh, we still see a problem here. Now I need to think, oh, wait a minute. How is that caused here? Okay, let me check this. We still have this case and this case. Is there a way to fix that? Should we add something like... No, if we do that, then we get like thick walls in this direction. What if we do... No, we can't do that. We have one case. Easy way, increase the resolution. Of course, but if there is if there is a proper way to solve that without increasing the resolution, then I would rather use that instead. By the way, we change it to wall here. Don't tell Johnny. He's probably not listening anyway, so let's do wall here. Here. No pink anymore. We have now only wall. So when is that happening? Oh, and we have like a stupid edge case here. Look at that. I mean, we don't need to care about that. Who needs to care about that? It will be just a dead end. I'm wondering why is it even ending here? Okay, this is all right. We get this case. I think we should look at different cases here. To solve that, we might want to, like, if this is, let's say, in and out, to change it, or in, out, Hoppala, out. No, wait, like that. These two cases. Oops. We might want to test it like that. The diameter is even, which is not great. We have like here, this is thicker than that. But, oh man, well, you're opening can of worms here. What's now? Look at, oh shoot. What have you done? What have you done? Oh no, what happens if I do? Oh, we might have a problem here. Houston, we have a problem. No, it's always like one off. Okay, we might want to wait. We need to. This is not all right here. Wait, square root. Oh, wait, a slice r. Oh, I don't use r here. I don't use r anymore, and this is like the odd even, but this is dx, so I don't get the problem here. Let me check if that's the center now. If we don't, we have like a perfect center. No. that still breaks, but for another reason here. Oh, we need like to tweak it a bit. Ah, can of worms. Dude, what have you done to me? Okay, yeah, I need to be more precise here. With the bigger, greater, and smaller than, especially. Man. Okay, no matter what, let's try to fix that issue here. And I will try now. Bloody heck, see the sequel is coming. Oh, let's try this pattern, okay? So if we get like a transition, like this transition or this transition, only in those cases we can get a wall. Okay. Let's keep that in mind. So let's try. Ay, too many brackets. Okay, pix minus pix. Okay. So this is the first case. No, +1, +1, +1, and 2. Wait, this and 2 is 2 and pix I. And just do 2 cases, pix I equals 1, which is a magic number here. I should really, or now let's do the other one. -1, doesn't matter which way around, and equals 2. Then material wall else. Do I miss a bracket? No, there is one bracket too many, too few. Is this the way? Nope. Let me check. Blue is completely destroyed. That's in, huh? In is what? Material wall in is 1. One gets completely abolished. Pix. Okay, in that case. No, that doesn't work. I need a smarter way. Let me think about it. I'm wondering if we should be able to overwrite it. So we are not canceling people on my stream, not even XOR. I mean, not even a wall. All right, okay, peeps. There's no worky. There was a comma missing, brackets, yeah, no worries. Missing? First row? No, no, it's, oh, was it? No, this is or, and, no, it's, this is like the complete closing if. Sorry for confusion. I don't think this did matter at all. Excel's. Okay. Let's. I think I'm on the right way. We should only look in one direction if the inner is. What Rota say? Yeah. If pix I equals 1, then do something different than. Rota's sleepy. Then do something different, okay? Okay, so where is the rotor? Okay, here we go. Now we are if pix I minus 1 or pix I minus x res yeah. Okay, this is what I do in that case, and in the other case I look in the other direction. I don't know what went wrong. So push material wall, and then we just ignore that part that's almost worked before. Yeah, nice error. Reading what? Push. Oh yeah, else. I should also do, I will simplify the code in a second, okay? Oh no, what is this trash? Am I that bad? It doesn't work in any direction now. Nice. Am I stupid? This is the right or. Yeah, this is the right or. In that case, I looked. No, this is alright. No. Foo. Okay, let me check something. Edge detection. That's a solved problem. If I missed something. Edge detection. If it does the same stupid thing. Or they're performing X and Y separately for the edge detection. Yeah, I see a matrix in X and Y separately. Foo. Are they? Oh, GX and GY. Now I see a diagonal. They always combine. It seems like they're combining like two directions. I maybe tried to do too much in one pass. Okay, you know what? F this. I ship it to Bleep Track now. Shippable. It's already wrong. Voila. I double process the same wall, which is terrible in that case. And yes, but I'm looking for corners like I want also diagonal corners, not only like corners, but I don't think that's possible in one pass right now without like overwriting the same array. So this will be like the simplest case. Yeah. Yeah, it was. So yeah, that's like, did I even save? Oh, was yeah. Yeah, that's just looking, there is not even a diagonal part. So what we want to fix is we want this diagonal pixel as well. And that one as well. It's like transition from, we have a transition from, wait, why is, here's red to blue, blue to red. It's always in that direction, but not in that direction. Because we look, check something else. We have to XOR either this direction or this direction, not both. But then we need to know what we do. We just need one thin wall. Oh, fool. Usually, I would not even consider this one here. So only like 2 pixels. But wait. That's wrong. -1, +1. But this is not what we do here, because we don't add like one pixel thickness here. So if we just want to, yeah, this works, but this is too thick already. Is it? Yeah, it's too thick here. There should be one less things. Why is it in Y thicker than? Oh, plus, right? Yeah, plus. Yeah, here. Or what? Or yeah, but I need to do either of those, not like both. So the problem is the OR does like the OR thing, but I need to check it in that direction or in that X or in that direction. So let me do that. Yeah, XOR, but what the but if we have a transition in both directions, then what do we do? Like, we don't do anything. We just keep it. That's no, that's not the solution. That's not the solution. That's not the solution. Okay. Let me do that. Okay. We have perfect X. Okay. Now let's do transition Y. Okay. Now we have still diagonal. Now we need the diagonal part, which is stupid. I mean, we can do this part in one. That's all right. But like do every direction in one pair. This is terrible. I hate it already. So minus x minus 1. Okay. Still missing this direction. Is it? Yes. We can combine 2 of those. But this is like Oh man. I mean, this is how a scientist would do it. I need to write a paper. That's why how I do it. And I only post pseudocode because yeah, I forgot how to do that. Okay, no, no, no. I'm not joking about scientists. It's shippable. It's shippable. Okay, we looking in minus x plus 1. Okay, that's that direction. Now we have everything covered. Here we go, multi-pass solution. Nice. Rob, 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 rob. That's what I wanted. That's what I wanted. That's what I needed here in my life. Words are very unnecessary. They can only do harm. Doo 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 doo. Okay, we have our layers. We have our model here. Now let's render and demonetize. Sorry, Dave, I can do that. Yeah. Rah, 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 rah. Should we export a volume? Is there a volume? What is this crap? Do you see that crap here? Shit, yes. That's oh yeah. How did you, what? No. Did you see that from my what? How did you? Come on. No, no, no. You didn't. Did you? No. What? Come on. No, 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 no. You didn't see that from that image here. Oh. What URL? Oh, yeah, yeah, heat exchange. Okay. It would be really good if you just saw that from the. You know what? I just screwed it. We don't care about those pixels here. For whatever reason, that's. Yeah, yeah, yeah. I'm doxed. I'm doxed. Why did it do it here? Not there. Yeah, that's all right. I don't care really. Now, do we want a finite element method simulation? We can assign temperatures. Math is hard. Yes. We can assign temperatures. Do we need some kind of simulate some kind of flow? I won't be like doing proper flow simulation. I will just we can assign a temperature to the let's do a simulation step, shall we? We generate a volume, or let's say we just take a slice, okay? Slice, and then we will render. Oh, this is so terrible. This is too much code already. One pix render, render, render. Yes. Okay. Let's do a buffer. Okay, let's const material temperature in Kelvin, please. So what is the temperature of a fart? Let's ask ChatGPT. Don't tell me 36 degrees. Oh, come on. 38.5. It depends on the on the yeah. In Kelvin, that will be plus 273. Okay, here we go. This is Kelvin. I'm sorry. So vacuum is basically zero. Zero. Then we have one will be one is in air. Wait. Material air in. So what's currently the temperature of the outside air? Let's say okay. Um, outside temperature is now 200 15. Okay, 315. Okay. Okay, so outside temperature is basically 10 degrees C. C. Far temperature. We can measure the heat of my seat right now with the thermal camera. Okay, the wall. What is the material of the wall? I will assume the material of the wall is like 20 degrees. It's like will be 4. So 2, 9, 3, 15. And diamond has also the same temperature. Okay, let's assume that. But okay, function temp to RGB will be basically T, and then return oh, there is no transfer between we should ignore that. Oh no, how do we transfer? How do we ignore? Oh, we need some sort of transfer coefficient. How is that simulated? Oh no. There's like a transition between materials. Ah, we need to wing it somehow so it looks good, and that will be all. Material heat transfer. This is 0, and then we do like 1. This is our that vacuum basically doesn't affect the temperature. Otherwise, it's very cold. Okay, so heat transfer. Okay, temp to RGB, and then we will have T. It's very hot. So from very hot to this is Kelvin. Min. Let's do. Shoot. Do we want really like this? Let's do only red and blue, okay? I don't really care. Let's do 40 degree, 250 or something. 250. No, 270, 307. 350 will be basically, yeah. I have an idea. How about that? Clamped T and then return. Yeah, let's do that. Yeah, it will look terrible. It will look terrible. We can still manipulate later. We can even change the initial part, so outside temperature will be Arctic or something. So 255 35, wait. Minus 100. So this is increasing hot. This is basically CT 0, 255 minus CT, and then that's it. And 255 because it's RGBA. Okay, let's do that. Temp to RGBA, then function mat to temp, which is M. And then return. Yeah, whatever. Oops. This is stupid. We don't need that. We have like this lookup table. Okay. Now we need to function. Yeah, that was the mat to temp. We just convert it. And we don't need the Z for now because we're only operating on one slice currently. But this is okay. Or do we add like a second canvas? We can do that. That shouldn't be difficult. Beneath that or next to it, we can do next to it. Let's do a second canvas here. Heat and match in the wall. Matte canvas, and there will be heat canvas. Yeah, stupid. Now I'm rebuilding everything. Function render heat. Function render Oh, wait. Okay, let's do it, whatever. We can use like the same stuff here, whatever. Okay, render mats. We are duplicating the code all the time. That's not great, not great. Matte colors and heat heat temp to RGBA, temperature. Let's keep it like that. And this is I temperature, heat, and this is render render or generate mats. Generate mat slice. And the pixels, that pix, and let's do it like this. Return pix. Wait. Tick, 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 tick. Something's missing. Oh yeah, two. Wait. We are not done yet. Pix, 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 return pix2. Return pix2, and this is getting yes. Okay. Generate mat slice. Okay, we will generate mat render 0, which is no. Generate mat slice 0 and then render mat, and we don't have heat yet. Okay. Mat to heat to temp. Oh, sorry. Mat to temp, and then render temp. And this is also render everything. Oh man. Refresh. We need something like refresh here, because this is like function refresh, and this will basically, or refresh or update it. Update 0. What? Update 0. And this will be slice. Oh, that's a function. Oof. Z render mob var material buffer. Or do we do let? Doesn't matter really. Material buffer and then temperature buffer. Temperature buffer. Okay, temperature buffer. So mat to temp equals temperature buffer and material buffer and render. Oh, wait. No. this is material buffer, render material, and render temperature buffer like that. This is what we want. Cleaning a little bit up, render temp, render mats, whatever. Render temp. Temperature. And this is this material, okay? So, oh, material, okay, let's go. We have the second canvas, matte canvas type, save to PNG, and this will be BR, Uppsalas. Nothing, okay. There will be many errors in console. End of input, unexpected, wait. Update, wait. On load, oh. On input, this value update. Okay, that's one thing. Wait, what? Update. Not defined. Where? What did I miss? Oh, just still not defined or what? No. On load is it should be loaded. Everything should be loaded, unless it. What did I miss here? 27. What? Why do I need to see this shit every single time I open this? Where did it break? Update is not defined. That's because the script is broken. But where is it broken? End of input? Wait, update. Did I miss a closing bracket somewhere? Save button, hex to RGB. Oh yeah, by the way, I don't need that. And this, okay, yeah, this is saving function. The temp. What is the problem here? Where? I've lost the bracket. Okay, let's start methodically. This is all right. This is, oh, I didn't implement it. I interrupted myself. Foo, okay. Let's yeah, but you will be on the quest for the tab and space mismatch if you're doing your probably Python stuff. Push. At least I was able to see where the bracket was. And you're lost in mismatching white spaces somewhere and recompiling your kernel. Okay. Temp push match temperature. Yes, yes, yes. Mud matrix. Oh, shoot. Yeah, let's convert it like I. Oh, you know what? F this. X plus Y times X res and yeah. Okay, material temperature push. This is what we want. Do we want that? And there is an update something missing. No, actually no. Material to temp, material buffer. We might want to swap that because we don't render every single time. But oh yes, okay, here we go. We have one. We have no temperature yet. Why? Why don't we have that? Is there something? Aha, here we go. Temperature, I, RGB. Here we go. Small typo here. Boop, boop, boop. Ah! Still? Let's throw it. What was... Undefined? Undefined render temp? Didn't I pass anything? What's the call stack? Oh, I didn't return it. I didn't return it. Turbo Pascal is cool. One of my starter languages. My second language. No! I did assembly first, I think, then Turbo Pascal. Strange. I bought Turbo Assembler before I got Turbo Pascal in school. I bought it with my own like money that I collected from my grandma every Christmas or something. Okay, here we go. Here we go, peeps. This is our heat. Yeah, basic assembler, Turbo Pascal, C++, Commodore Basic. It wasn't a mess in 16-bit mode. I mean, then with protected mode, everything got more complicated. I never did Delphi. From all those. Oh, really? Are you using? Do you like Python? Your honest opinion, please. I won't judge you. No worries. And why I'm doing a simulation step here. Okay, I will do a simulation. Wait, didn't I want them to be next to each other? Oh yeah, they are. You really? Maybe we should do 228. Wait. Punch cards, but you still have to do machine code, so it's some sort of assembly. Yeah, it's basically the evolution of Pascal. Okay. Okay, we got a better visualization here. So the vacuum is quite cold. It's not even vacuum, that's like, you know what? Material density. We will use material density for that. Okay. Uh, oh wow, he did what? What's the name of the guy? I need the name. Best dude ever, huh? Okay, then now I need to update or function sim step. Okay, let's do sim step, some delta t dt, which will be always 1. Sim step will be dt, and then function refresh, which will be basically, or draw, let's call it draw, and draw will be render, draw. So we, Uppsala is also Swedish city. Heisberg, Heinsberg, like healthy mountain. SimStep, okay. Now draw SimStep, and we need the buttons to SimStep here. So we need the button to sim. Yeah, I don't need food is on click. Oh, what was the function name? SimStep and draw. SimStep and draw. Okay, SimStep, and we will do like 1 and draw. Okay. Now SimStep doesn't do anything right now, but it could do. And what we need is temperature buffer here. Let or const tbs, so we don't have like super long names here. And now we will do y, x, y, z, blah, 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 Mr. Freeman. Okay, let's do const here. I mean, we will still swap it at the end, so TB, okay, let's do TB0 and TB1 is equal this, because we will just do this. And then we will be temperature buffer equals TB1 at the end. And now we will do the following, my friends. Stay a while and listen. Okay, TB cons TB1 B1 push TB0. Let's go I++, or let P or I, so I don't have to multiply all the time. So that will be temperature, material, I. Oh, wow. Oh no. Clip. Do we? Oh, we need to clip at the borders. Do we do it the lazy way or the good way? Good or lazy? Let's do it the lazy way, okay? Yeah. Okay, we will just copy. No. That's true. Okay, here we go. Else we will do the fancy schmancy calculation. See, the borders will always stay the same temperature. Okay, TB0 times const mat0 material density times, oh no, foo, we need the total. Let D0 be let D0 be. Oh, we need some sort of. Oh no. Okay, this is a stupid way. We need a different one. What is the for propagation? Let's just get density. Mat 0 I minus x res. It's all magic numbers still. No great. No! Stay, please! Okay, no, this is like minus, oh, whatever. Okay, minus 1 and I and plus. We're almost there. You will see a simulation in 12 minutes. No, 1 minute, 2 minutes. Okay, we just got the densities of the materials. We can change them because air has different density, vacuum has no density, not transferring any heat. Okay, we just take the densities, and now we take please please stay please. Okay, d times d2. This is a simple formula. We will just do the average of all the neighbors. No, it's not. It's not. Trust me. I'm a loony. No, don't believe them. They lie. Almost there. Plus 1, minus 1, minus x res, minus x res, and this is. Hold on, it's almost there. 4, and then we just need to multiply it by divided by a total. Divided by 2 plus the 3 plus the 4, and we only need the exception for. Okay, let's sum for 0. So in that case, we don't change anything. Okay, so we just need this sum here. Let's sum be that, and sum, and if sum, otherwise nothing. Otherwise TB push, and basically TB1 else. Oh, come on. TB1 push TB0I. That's it. Now we have a simulation step, hopefully. This is what happens with the temperature. Okay. Okay. This is the simulation step. Okay. Now we need different densities. I just need to add densities. Density aluminium. That's 2.7 gram per cubic centimeter. Okay, let's just go. This is 2.7. Okay, this is 2.7. Density air. What is the, this is not. Oh, okay, we have 1.204. It's air basically, but it might be a little bit lower because it's heated up. Okay, now we need. That's a square. Oh man. It is convection basically. Grams per square. Where's the, how do I calculate? Oh, come on. Grams per square centimeter. How many square centimeters do we have in 1 meter? That's 100, 1 by 100, 100, which is 1 million. 1 million, and this is like grams. 2375. 2000. No, 2070. This is aluminium, and diamond is basically, we don't need diamond. We don't use diamond here. Okay, so this will be the simulation. Oh, with gravity. Okay, let's try a different slice. Oh, now we need the moving air. Basically, the standing air gets immediately changed to the temperature of the aluminium. The aluminium has. Oh shoot! Okay, air is too dense. Am I right? It is like 2.7 tons per square meter. Yeah, it has to be. Yeah, it is. It is. Okay, we need flowing air. Now we need. Oh shoot! How do we simulate flowing air? The air movement. We need to. Oh no! We need a vector now. Oh no. Dudes. We can fluid simulation. No, 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 no. No, 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 no. We don't do. We just assume. We just assume that. Oh, how? Oh no. We. Oh, shoot. Oh, there will be pressure as well. Oh no. Oh, foo. This is terrible. This is a terrible simulation. I should be ashamed of. Okay, let's render a volume. Should we export a volume or render it first? Okay, thank you. Whoever wanted to stay. I mean, I will continue for half an hour because we just started. We can. We can now do like actually generate a volume out of that. We should just simulate that and export it as a volume file. We can even wait. Is there a volume file that's format that we can basically use? Blender volume. Is there like a file format? I really don't want to like. I mean, we can just check out. I wrote volume renderers. I made even my bachelor thesis. Volume rendering. Really? Okay. We have a step here where we can export this volume here. The simulation is all right though. Should I? It's still in the context of fart temperatures. Okay. Um, let's see. VDB, VDB, open VDB. What? What is VDB file? Volume database file. Yeah, of course, Blender. But they're also used in other softwares as well. VDB file, how to open VD. Come on. Well, I'm looking here, open VDB file list now. Open VDB. Examples Python IO3. YouTube. What? What is open VDB IO? Grid H types version. Hierarchy. Oh, that sounds complicated. Tree of bricks. A brick is a fixed size cube containing a portion of the volume data. The size of a brick is determined by the user, can be adjusted depending on the resolution of the volume data. Okay, so it's like an octree, more or less. Yes. Open VDB library. Okay. VDB.js. Ah, that's an NPM. Set value, get value, grid access, VDB grids require. Shoot, but I can't use NPM in like this here. This is import grid from VDB.js. Is this like, oh shit. And the version isn't even one. OpenVDB, JavaScript, source, OpenVDB, math core debug, dependencies, index.js, core math. That's like super complicated. That's the worst format ever. I just want a what? Not sorry. Node.js. Okay. Node.js. Oh wait, we can use maybe a open VDB converter. I don't have Node.js here. What do I agree to? I don't know. What is? Okay. What is this shit? This looks totally suspicious. That's, what is this shit? I don't want this. Production releases. What is this? Mathematica. Tools. Yeah. Why is this? I mean, we can just do a vol format. I don't want like to study this stuff for ages right now. Okay, let me check something. Stanford format. I used like triangle form. Wait, Stanford. I use those for my studies. These are like volume grids, CT slices. Wait, this is CT head info. Okay, that's files. This is the Stanford bunny. No, yeah, that takes a while. But CT scan, I hope. Oh, wait, that's 360 slices. Oh, okay. Yeah, that comes as a yeah. That's basically. How did I do this? 3D polygon mesh tool. What? Where did I use it? Where's the polygon mesh tool? Q splat models, CT scan, scan view, drill. No, this is splats. multi-page. I'm just looking at the possibility. I mean, the easiest way would be like to import it in Blender somehow, so we can actually render it. So let's check material. If we can like see, it's really too hard to ask for them to give me the weight. How this is like. It must be there must be some more ways to generate a volume like this open VDB format isn't probably the only one. How do I determine where do I materials? What is the settings? Texture, image or movie. Or movie, okay, image. What kind of image? Preview, image settings, mapping colors. No, open. Yeah, it doesn't say what formats. Shit. I'm wondering. Okay, these are 2D object. Yeah. Open VDB from slices. Open VDB cookbook. Nice. I don't want to compile stuff. Why is this? Isn't there like a tool online? Please. Huh? DICOM files, yeah. There's even 3D DICOM, but it's off spec, I think. I don't know. I have old volumes. Maybe, you know what? You know what? Let me check out my old renderer. I don't know if it's still running. There should be like my bachelor thesis. There should be like a volume renderer that's quite capable. Where's my code? Oh no, I don't have to. Where's the code? What? Look at this. This was my bachelor thesis. That was like a volume renderer that like did calculated like slices. Yeah, okay. It had like a transfer function that was like state of the art back then, like gazillion years ago. That was 2006, and it was capable of doing intersections between volumes and meshes to like do like any yeah, oh yeah, with transfer function and so on. So you could basically cut out stuff and intersect and whatnot. So basic Boolean operations on CT and whatever volumes, and combined. This is MRI combined with CT, and there is like some sort of polygon instrument inserted in that. Yeah. Yeah, but I think that I did never. I never. I don't have the software because I wrote this thesis at work, and I think the code was not mine at the end, but I might have some standalone software somewhere. Hmm. Box. Does box try? How did what? Oh no, this is old stuff. Fetch thesis. Oh, wait a second. Shader toy. We can also use shader toy for now just to get some sort of render out of that. It uses some kind of better. It supports. Yeah, except it also uses a binary. Oh no, yeah. It would be nice to have like an export of the volume. I can still do that, but browse what? Okay. And Mike is back. I'm sorry. It was actually really dead. Okay. Where is the information about volume text? I found like shader toy media files, but how does it? Volumetrics, is there? Slideshow. Oh, that's a Voronoi. Textures, okay, interesting. Volumes. Oh, noise, RGB gray noise. How do I define that? New, okay. Or let me just get that. You can use the keyboard input. How do I zoom? Oh. Huh? Just like a huh? Oh, okay. A gets a smooth rendering. Okay, this is a volume renderer. Let's just fork it. And let's see. This is Raybox. Get voxel scene. Fetch smooth skybox. Main image. Wait. Texture channel 1. Yeah, that we can use that shader, but we just need to get like how we load the texture there. Main image, okay, skywalks, get voxel scene, which is basically, oh yeah, Dexel fetch smooth coordinate resolution. Oh yeah, that's basically the difference between pressing A button and not. Oops. Here. Smooth. Fetch. Smooth. Excel fetch 3D channel 0. What is this channel 0? Select input. Oh, here. Wait. Buffer A. Oh, yeah, that's the noise. Lerp. And this is buffer. Oh, wow. It's like multi-pass thingy, but image. No, that's the ray box, ray sky box. It's a little bit difficult. It seems like it's too many passes for a simple volume render on main image. Okay, this is the image of skybox. Okay, so this thing is that. So the navigation and so on. This is main image somehow. So there's like two passes on that.
Then we have distance transformation, frame texel fetch. Okay, so this is some sort of traversing. Yeah, that's basically that, but you can load. So this is noise hash lerp solid. Resolution sample text fetch whiteboard text fetch 3D. Ah, okay. Let's read the documentation. SDF scene. Distance transform algorithm. Remargin common noise. Okay. Yeah, but if I do buffer A, what is this hash here? Like 4 metaballs. It's not well documented, I must admit, because where's the distance transform? You get like always this main image, but okay. Texel fetch smooth 3D. That will be channel 0, and channel 0 is where's channel 0? How is this mapped? Wait, lerp, mouse zoom this. Solid gets seen. Frag coordination. Coordinate what? Actually, I don't know. Frag chord. Frag chord. Text fetch smooth. Is this like stored, the texture stored in a 2D array? Because I don't see, where's this? No, this is interpolation. Okay, it takes me too long to investigate that. Let me check. Simple Voronoi. Oh, there's even a fluid simulation, fluid volume. That one is simple. SDF, and that's a noise. Channel 0 is textures, cube map, volumes, noise. There are videos, but can I upload it somehow? It would be interesting. How do I use that? Okay, let me check that one because it's non-commercial share, like unported license, multifractal, channel 0, bounding strength of bounding length, main image, intensity, resolution. And it's the epsilon. Out, resolution, normalize. Yeah, these sendings are just ray marching, huh? Smooth step. Uh, there's like different levels of noise. That's interesting. Strength. Okay, I think I'm not getting anywhere so quickly. Let me just do one last pass on in my renderer here. You need, yeah, okay. No, it's all right. I will just do a simple rendering of the slices here to make like an orthogonal just mapping here. This will be, I will just do like one last thing. So we see a 3D volume here, a 3D volume. I can even generate a file for now that's with some spec, with just binary. Or we can do a texture that is basically all slices underneath each other. So we'll change canvas size and do like 80 slices, but it will be long. Huh? 3JS? Oh yeah. 3JS. Volume rendering example. Oh yes. Now we ah, dude, that might be it. Examples, WebG, materials, texture, 3D. But how is it loaded? Because that looks like an... Okay, let me check the example here, the code. 3JS sources. Let me check where or network, so I see where the volume is. Data application font fetch PNG. Where's the volume stored? Blob. Okay, might be that blob here. Or is it? Material main CSS. Okay, viewport. Let's check import map 3 module. Three pixel ratio, append document, DOM element append child camera, position up, orbit controls, targets admin zoom enable, loads the data, stand NRRD. That's a stand for cardiac stuff. Anaglyph glasses. I have anaglyph glasses, but no, it's not stereoscopic, is it? No, it's just... No, that's not anaglyph. This is a stand data from a cardiac or whatever. That just, yeah, that's just surface color mapping, and yeah, if you map gray. But yeah, but this is actually what I want. Data, volume data. It is like NRRD. What is the volume? We have scalars, so we data in the red channel. We'll select F based on the tree red format. What is that? N-dimensional, oh man. Definition. Encoding raw, UChar dimension, tree size, header. Okay, so basic header, I think we can do that. And then we will use just this example to load our volume. That I can do. Let's see, where's this material web to GL material texture 3D texture main examples. Okay, let's check that out. That's loaded, so probably okay. Let's get that file from wherever. 3JS examples. stand. Oh, that's only 800 kilobytes, which is all right. Show in folder. Let's see. Okay, here we go. It's binary after the specification encoding, and there is like this gzip. We can just use raw. So there's the format specification. Image IO, Python image IO library. Oh, okay. Type float, dimension 3. Interesting. We only need like uchar or something. Okay, so these are the specs. Okay, we got somewhere. Unfortunately, I'm already tired, but we can still do. Raw and ASCII encoding as well. General, open encodings. Okay, meta image. Also, let's get that file so we can check that out. Maybe we can see. Um, okay, this was stand, and it ended with AA, and then it just starts with the data origin, two returns, and then it's starting with data, and the new one unconfirmed. It's still downloading, huh? No, wait. Okay, here we go. AA, yeah. Okay, so origin, and okay, let's look at the file in edit notepad. So I have an impression. Okay, we don't need command. What is the all for? Okay, yeah, let's use that. Let's use that. Let's just copy the format. Okay. And we will start from that. Oh, is there a trailer? I don't think there is. It just might just end. Null, null, null. Soch. And the last one here is, what is SOH? No, no, there is just a file, and it's probably intrinsic with the resolution and whatever. No, it's all right. Okay, so we have return, and then basically the raw data. So this type is float. No. Oh no. No. No overwriting here. Let me check if there is like a raw. No, it's also little endian and gzip. Okay, we will do little endian, but we will do uint. Space origin will be I don't care. Yeah, that's basically half of whatever. Okay. What we need now is this will be. I need one change here. Transition depth is basically z res. Okay. Okay, that's and z is 0 right now. Okay, here we go. We start at 0 here. Where is our code? Okay. Eh? How do I break it? Oh yeah. I need to also change the code. Okay, good night. Yeah, I mean, I will export the volume and then we will go from that next time maybe. I don't think I will finish working renderer today. I might if I can get 3JS going. Good night. Okay. Transition depth, which is basically z res minus whoop. Opala. Can I run Node.js from here? Web Chrome, install extension. Wait, can go live server, workspace. Okay. I think is this running Node then? If I go live here, because I need probably for 3JS I need an environment, and that's the worst part right now, not exporting the file or whatever. Hey Ray, you're still there. Okay, I fixed that file. Hoppala. Yeah, okay, that worked. Now I need just clone that. What kind of return was it? 10? Yeah, it was a. Yes, it's 10. Okay. Is this R or N? That's N, okay. Let's do here. Function generate volume. volume, and then I will basically for let z equals 0, z res z plus plus, and then do the following: generate volume, do we use this is interesting now. No, generate what? No, wait, what do I do? Generate mat slice, which will be z, and this is now the material, and we can generate the volume from that. Okay, so let volume be an array. That's basically all the slices, and we will just const mat slice equals generate the slice. That is possible, and then let's get y I should just copy x and y somewhere else. Oh, tired here. X. Okay. Yeah, we can do that. We just take the aluminium. If mat slice I equals material wall, then volume push someone left. Oh, we can do new uint 8 array, and we know x res time y res time z res, and that's our volume. So we have actual binary volume already here, and now we need let's do this will be I, and there will be a J here, which is stupid, but all right. So each slice and each I volume I equals, that's a material wall, which will be 255, and else will be basically empty. Volume I will be 0, and this is J. Okay, this is our volume generated. Okay, nice. return vol, generate volume, and then function generate header. What's the name of the file formats? NRRD. Return, and now let's go. I hope this will, oh no, is this like some Unicode then? We can ask ChatGPT. Let's reload. Char code to string char code. Okay. Okay, we just check. I think we might not be in trouble with that. Okay, let's go. This is like const header equals, and now let's, what is that? Why, how this came to life? Okay, and plus whatever, and then we return header. Okay, this will be last thing will be n and an empty line. And this is the last two. Let's start with the definition. So header type, that's all right. That looks like a nice simple header. Okay, now sim. Okay, this is our type. I think that was O. Was there a specification? That's just uchar. Okay, type is uchar here. Uchar. Okay, dimension 3 is all right. Plus size. Now it's the size, which will be plus xres. Oops. I hope this is the way around. It might be like zres, like inverted and we will see zres plus. Okay, encoding will be raw. Endian is little. Space directions, whatever. Space origin is also whatever for now. And this. Okay, this is the header. Data URL, download canvas, okay. Store or function download RD file, and then we will do the following. Eventless click. Okay. So to data URL, not canvas to data URL, we need a writer or something. Blob writer. Okay. Combine blob string. Okay, that looks all right. String to blob, text plain. Oh, this is all right. Oh, nice. That's actually what I'm looking for. Thank you, ChatGPT, for not letting me look in my old code or whatever code, or here we go. Data URL. We just get blob. Just clean code string blob. So this one is return header. And then combined blob uint array, which will be generate volume. Volume, octet stream, data URL. Okay. Create element, downloads, Maybe we can just use it, append child, click, remove child. Nice, download unRD. Now we need just a button download volume and we are done here. Button, on click, download unRD, and that's it. Button. Get unRD. Okay. Let's see if it crashes, huh? Oh, it actually did it. No, don't tell me it's first try. Nope. It's a 1 kilobyte volume. Okay, let's moment of truth. Let's see what the result was. Bitluni vol. Here we go. Okay. Okay, I got it. I got it. I got it. Get volume. So it just stored a function. Oh, wait. Generate volume within brackets here. That's all. Okay. Oh, 800 kilobytes. Here we go. Oh, it's full of zeros except for this. Oh yeah, that looks like a reasonable volume. Okay, okay. If that works. Easy, easy. Okay, peeps. This might be a volume, and I might be done with at least opala, night. Yeah. Okay, so now oh wait. Oh, dimension is of the color dimension. Okay, okay. While where are you? How are you? What? Are you lurking all the time and just now saving my ass here? This is awesome. I thought I'm on my own right now. Okay, okay, now we just need the 3JS. You joined the how do you know? Do you know tree like no, how do you know this format? But you're right. I mean, I missed that part because we have only like or is it dimension? No, it was color dimension. Is it? This one was, let me check again. 3, 3. Oh, okay, okay, okay. Let me check again with the specs here. What's dimension? Space dimension, basic field specifications, dimension, array of start, grayscale images for scalar volumes. No, it's actually dimension float, weight, type. For scalar, no, wait. Histograms, grayscale volumes.
grayscale images for scalar volumes and color images. Scalar volumes. Wait. Time varying scalar volumes. So it's three actually. There are no like. Oh, that's really odd. We might be still okay. We leave three for now, but we might be like it's a strange specification because color and space dimensions are like mixed in that case. It seems I don't know why and how. Okay. Let's try now. How do we how do we run 3JS now from here or use we can we need to fetch uh, brain viewer, drop files here. Oh yeah. Oh wow. We got only the one thing wrong, I think. There is a shift. Okay, the threshold 255 is too high. Ah, no, here is the threshold. There is a shift. Oh, I'm confused now. X. Oh, wait. There is a shift. It worked somewhat. I need to be 255 needs to be excluded for that one. 3D. Oh, yeah, that's. What is wrong with that? Okay, this slice. Okay, let's start. This slice doesn't matter. We never look at that. Yeah, I think we need to reorder, change the order of the dimensions. Change the order of the dimensions. Basically, what we want to try is maybe 80, 102, 102. So that's what I thought might be wrong as well. Okay, now let's reload that. And see, nope. It was right. Except we have something's broken there. Is this broken, my exporter? Okay, that was correct before. But why was the volume shifted? Why is the volume shifted here? If you look at this slice, everything else is correct. Except it's shifted here.
I mean, it's also clipped a little bit down there and up there and whatnot. Okay, this is one of the viewers. Let me check brain viewer. Three. Okay, let me try that. Drop files here. Blah blah blah, Mr. Freeman. Field of view, what is that? Exposure. That's not, that doesn't work really. On RD. Dicom to un, oh, interesting. File compressed on RD for medical viewers. Okay. It's still the same. Oh, it's probably the same renderer even, yeah. Looks like it's the same renderer. But I'm not sure what is happening here. Why do we have like this shift? I need to check my data. Hey, Sion. Origin. Okay, yeah, we can try without space directions. X, Y, Z, which is alright. Uchar. No. That's even not. Yeah, no. Didn't help. The origin didn't help. It's strange because it's like it's shifted by 60 pixels. What is our resolution? 100. Oh, it might be if it's 40 half Z. I don't know what. No. Yeah. So what we did is I generated so for heat exchange system with inflow air and outflow air and some aluminum that's like a pipe, and these are the slices, and I exported in volume, and I'm using now a renderer, but either the format of my volume is broken or something I missed something in the specs of the NRRD. At least this renderer draws it wrong, which is not great. Let me check that if I missed there something. NRD. Oh yeah, that, oh, we can try that. That's a good idea. Yeah, but don't. Yeah, yeah, that's looking all right. They're also compressed, so shit. These are compressed. but I still don't know what resolutions. Okay, I can try, I mean, I can compare with the stand file. We see that's still loading. That one didn't load properly. Or do I have like, here, okay. The range. Does it show any specs of the volume? This is hard, the window. I can't control the window here. Why? Oh, yeah, this is broken SF. Okay. No, I can't tell. I can't tell. Okay, let me check if I see something wrong with my one. X, Y, Z, U, and Z. So we got I plus plus, volume I, that's, and here is J plus plus, slice. I mean, I could try to, let's try something different. Let's try doing 102. So we have the same resolution in all dimensions, okay? We can do that. And basically get the specific volume for that in all dimensions. Bloop. Select the file. No, still shifted. What did I miss here? And I also want to try the different max value. We can even try to do different materials here. So let me do, yeah, let me do just 200 here. Okay. Oops. Okay, now we got rid of the errors. It's clipping at 255. Oh, and I see it's it's clipped here, so it's shifted in that direction by 2 slices, in that direction by many slices. What is going on there? Okay, let me check the specs. I didn't even read the specs yet, so okay, let me get the tab. General information, field description, key value, comment, da 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 da. Okay, space dimension. So this is the 4th format. I can increase the size so you can read as well. ppm header. Oh, interesting. This is wasn't ppm. Yeah, it's similar to ppm. You know what? I might have extra data through the blob. Did I get extra blob data? No, it doesn't look like I have extra blob data. Let me get the volume in here. Okay, so AA, and this is where my volume starts. There is some extra data. It looks like what is this extra data here? Wait. Look. Here. This is like more or less sliced minus a few characters. That's like how many characters? 62. Is this right? 62, and from here to here is 61. Oh yeah, these are two lines. Yeah, okay. It's all right. This will be like 100, whatnot, 120, oh, 92. Yeah, that's all right. No, this is all right because I have like two clean lines. Good night, Ray. And there is like this filled chunk. Okay, I have an idea what to try right now. I will do the following. I will try to, or let me read first. ASCII encoding floating, no. Raw, space orientation, nope. Yeah, that could be an, let me check, int 8, signed char, uchar, unsigned char, signed char, short, u in long float, blob. Encoding. The data appears on disk exactly the same as in memory. Byte values, byte ordering, write, fwrite, raw, hex. Per byte, 2 hexadecimal characters per byte. White space characters are ignored on reading. Opala. Okay, I have an idea. I find what we can do is just not using 0 here. Let's use something like space. And here we can use like uh, character 64, which is a capital A. Let's try that. So we have not like stupid binary stuff. We have like something that can be. Let's check. Oh, 65 is okay. Yeah, we can live with add. But this is basically spaces and like readable characters which won't be clipped or transformed or whatnot. And now, oh, what else? Oh, I have even more ideas. I have so many ideas right now. Okay, still broken. Still broken. I don't know what's going on there. It's still broken. Broke. By the way, I should be able to max. So, oh, good night, Step. You're still awake. Oh man, don't you need to go to university tomorrow or something? Okay. Oh wait. Okay, these are like 102 slices for, and what we can do now, okay, since this is shifted for whatever reason, we have more of those blocks here. What is this one block? Oh, this one block was the line separating in the center. Okay. Yeah, get good sleep, man. And what else we do? We don't write, okay, that didn't help, so screw that. We do still like 200, and now we will do the following. Oh, no. We do, yeah, 200, and here we do the following. Math min x and y. Okay, this will be strange, but trust me, I'm I'm an engineer, software engineer, but an engineer. Here we go. Bam. Okay. What? Wait. Okay. Where does the shift start? Okay. We have the shift here. Oh, we need to start with which direction it started. Oh, come on. Okay, let's do X first. I will just completely clutter my hard drive with volumes. Okay, 6. Okay, so these are the slices, and wait a second. Okay, this is the shift. The shift happens in X. There is like a bam. And it's even more because the volume is even more shifted. It's like, I don't know what this. Okay. shift is definitively in X, and Y maybe, but why is there shift in X? Let's check if we got the Y shift here, okay? Y shift. Okay. Okay. Yeah, there is 2 lines of shift in Y. There's like a warp around or something. Why though? You can see that there is like this line that shouldn't be there. How and why? What is that? I mean, otherwise, you can see some sort of whatever that is. uh, let's do this is the opacity, okay. Yeah, that's interesting. Oh, I see something that we can even like improve on. Oh, give it like a tip here. Oh no. Yeah, this is still not done, but it's some sort of, yeah, this is interesting. Okay, still shifted. I don't know why. Why? I don't see it in the volume here. Okay. Let me check if we can get. Oh no. 2000 source, yeah, source forge. Nah. Team. Shoot. Oh yeah, ITK Snap. I used ITK sometime before Snap. Alternate ITK Snap Home. Okay, downloads. Self-install package. Yeah. What? I don't want to skip. Okay, I don't want to download. I'll try that first and get my free virus right now. Okay. Yeah. It's funny that it's also called Slicer, like the 3D printing software. Wow, that's installing a lot. Oh man, so many files. Are they crazy? I don't want like to whatever they're doing there. This is like cluttering my system. Okay, 3D slicer. Let's see. I'm wondering if there might be a problem when uploading or something. Okay, interesting. The software runs. Add data. What is add data? Choose a file and oh man, downloads. This one will be one. Okay. Show details. Load failed. It's quite informative. No. I thought 3D programming was VR IDE where you work around. No, you're doing volumes, but apparently it's too old-fashioned. Applications, all big image. What is big image? Nah, okay. Chest imaging platform. DICOM converters. PET to DICOM diffusion. Oh, wait, let me check something. Let me check the other volume if that loads. That one loads. Okay, so there is something wrong with my file format. If it doesn't load my file, but it loads this file, now we need only to find out what the problem is with, okay, let's open that one. Oh, interesting. It doesn't load all the files, it loads this file specifically, but not... Okay, so this is not reliable. Discard modifications. ITK Where's this? ITK snap. No. No. Screw it. Okay. Online file. Open main image. Browse. Trouble reading, trouble passing space, direction info. Don't have valid space. Okay. Okay. Space dimension info. Or direction. Space. What was the error? Let me check that. Okay. But this is like more open main image browse. Okay, this thing. Let me open this one. Stand is also space dimension. Okay, so that we should check for a better example than stand. Let's go that one. Oh, spacing of 0 is not allowed. Spacing is 0, 1, 1. Okay. Wow, that one is picky with the headers, huh? Okay, let's check what we got. Space directions, space origins, space dimensions. Yeah. Yeah. Let's do that. Okay. Okay, interesting. Time points, origin, little endian, character, metadata, finish. Oh man. This is our volume, my dudes. It's Wednesday, my dude. No, it's Thursday already here. I wanted to go to bed like ages ago. Where is the volume? I don't see the volume here. But this is reading the file properly. The other ones aren't. What is the Oh man. Okay. This is working well. Now let's try space directions, origin and dimensions. Let's just remove that crap from our exporter, and we don't need that. We don't need no education. Here we go. Let's do a 3D volume then. Math min x math oh no, we should maybe max even. No, max z, That will be interesting. So we see some sort of, we can also, probably the other renderer will also open it now the better way. I'm wondering if, okay, 8, if the brain viewer works, if it has a similar problem but wouldn't recognize it properly. No, it's not loading at all. What did I do? Okay. File, open main image. Okay, that worked. Ah. Okay, finish here. Min, max, z max and x and y is min. So we have some sort of volumetric display there. Oh, should we export like our simulation? But the simulation works only in 2 dimensions, not 3 dimensions, unfortunately, right now, because I mean, we could do it for 3 dimensions first. We probably even didn't see that yet. Okay, here we go. So this is like the heat transfer simulation, and we have like material density. We have air, this is vacuum, it doesn't transfer heat at all. There is no radiation or anything. This is like room temperature, 20 degrees C. This is like a 10 degree, no, yeah, 10 degrees C, and this is like 4 degrees C, so 37 degrees C. It's all in Kelvin. This is 0 Kelvin, blue, but it's clipped at minus. Where did I clip it at? Where did I clip it? Where did I clip it? I clip it at some cold temperature that never appears anyways. And if we simulate, basically there is some diffusion, but in our simulations it seems like the aluminium stores so much heat that it basically completely changes the surroundings to its temperature. Yeah, the air here, you see, it's still, yeah, that's always like one time step, 1 dt. Could let it run. I don't know, I didn't implement it just to let it run and animate. Could animate frame. Oh, but it will basically, yeah, sim bloop. Yeah, there is no airflow in volume right now. We don't have a vector or anything, and bloop. Apparently aluminium is way heavier than air or vacuum. It's cool. Like I don't know like what the problem is with loading the other volumes. It's here this loader doesn't like our volumes for some reason. Maybe because I don't know. I don't want to guess anything. Guesstimate. ITK apparently is able to read the file as it's supposed to do. And now I'm just curious. That's cool. I'm just curious how to see a volume here. All labels, paint over label. Can we just add a segmentation? No. Yeah, could be. There's something broken, but why would there be a shift or anything? Hmm. What is the label? And what is this 3D view? Can I somehow, do you know like how to use that? Wax tools, image contrasts, active 3D tool, no, spray paint tool, active 3D. Do I need some kind of transfer function? No. 3D. Oh, it always defaults to different screen. Marked region, but how do I mark it? Oh, it always moves the window. Label opacity. How do I add label? Active. Yeah, I have no clue. Label editor. What is the label editor? Okay. Label editor. Opacity. Okay, we have some labels. How do I display? What is this view here? Uh, hmm. Okay, I have no clue how to use this tool. Zoom inspector. Smooth curve. Add another image, resend, save, export. Okay, one thing is here. image slice, screenshot, screens. Can I store it, export? No, I can only export the slices, but I can't store it. Ah, shoot. It would be interesting if I can just store a different format. How do I assign? Oh, what is that? Oh, that's a mini map. When it doesn't fit, I get a mini map. I want to assign a label. Let me assign a label. Info, color map, grayscale, hot. Interesting. Contrast, segmentation image. Oh, I can save the image. Wait. Let me check. What it does. What format it did. Oh, it increased the size, double the size of the format of the file. Let me check what it's written. Short. Okay, it did short. Space, left, posterior, superior, kinds, domain, little, raw, space, origin. Nothing else. I mean, I could take this format and compare it to what I output if I export short. That would be a thing. But not today, my friends. I'm done for today. Oh, one thing that I could try is now import that one here. Okay, let's import that one here. It's loading, it's uploading. Oh no, it probably dies because it's too big. How big is the file? The volume is too big. It crashed already. No. Let me try another server here. Yeah, I would like to use the 3JS. We can try 3JS next time. What do you think? Yeah, these folks leave and leave. No, that doesn't load. It died. It probably died already here somewhere. Let me check console. Yeah. Byte length of int16 array should be multiple of 2. It already fails at the import. Nah, that's. Let me reload. Select file. Yeah, no, that dies. Okay, peeps. Thank you everyone for watching today. It wasn't like as much 3D as I wanted, but we had like a finite element simulation, volume export, no rendering, unless I just implement my own renderer. It will be hard to do so, and it seems that all the tools use different formats, and even between between the formats. There are some minor differences. The best would be just a raw format of 256 voxels cubed. Okay, thanks everyone. See you next time. Bye. How do I end the stream? How do I end this? I didn't eat my chocolate. Ah, darn. Here we go. Oh, only 2 people watching. Okay, bye bye.